The final day of stable reality. Do you remember the quiet confidence of a world that made sense? That simple, unspoken promise that tomorrow would be a lot like today? It was a silent contract we all signed at birth, backed up by every sunrise. We leaned on it without ever knowing its name. We just called it reality. It was the steady hum of traffic at 8 a.m., the bitter punch of a morning coffee, the reliable return of a loved one at the end of the day. This was the architecture of our lives, and it was all built on the assumption of solid ground. Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. We took its stability for granted, the same way you take gravity for granted. You just assume it'll always keep your world tethered and sane. This bedrock of predictability is what allowed us to build careers, to dream of the future, and to worry about things like deadlines and dinner plans, instead of worrying whether the sky would still be blue in an hour. It freed up our minds for everything that mattered. But what if you knew that all of it, the quiet mornings, the predictable routines, the very ground beneath your feet, was about to end? Forever. What if you learned that the contract was void, with no warning? This is the story of the last 24 hours of a world that was blissfully unaware it was about to disappear. This is the final day of stable reality. The deceptive calm. It begins, like all days did, with the mundane. An alarm clock cuts through the dark at 7 a.m. For a man named Alex, this sound isn't an intrusion. It's the first note in a daily symphony he's conducted for years. It's the first piece of proof that the world is still working. He swings his legs out of bed, his feet meet the floor, and the floor holds his weight. Another test passed. In the kitchen, the ritual continues. The faucet gives him cold water. The coffee maker gurgles to life, the refrigerator hums its steady tune. Each step is a small confirmation, a tiny vote of confidence in existence itself. This isn't just a morning routine, it's a checklist he doesn't even know he's running. Light switch works. Mug doesn't shatter in his hand. The news on the radio delivers the usual political squabbles and a cheerful weather forecast. It's all so beautifully, reassuringly boring. This is the very essence of what we lost. This was stable reality at its most potent. The rhythm of the everyday. A pattern so reliable it became invisible. We didn't realize our sanity was propped up by such fragile pillars. Some philosophers tried to warn us. They suggested that reality wasn't one rock-solid truth, but more like a negotiated agreement. A structure graded on its stability, held up by three pillars. The first was experiential immediacy *, the raw, undeniable data from your own senses. The thump of your own heart, the warmth of the sun on your skin. If it feels real to you, it is. The second was intersubjective stability *, the things we all agree on. We agree a chair is a chair, that red means stop, that certain historical events happened. It's the shared story we tell ourselves, reinforced by billions of people every single day. The third, and maybe the most important, was functional effectiveness *, the laws that work whether you believe in them or not. Gravity, thermodynamics, the engineering that keeps bridges standing and planes in the air. It's the world's operating system. Stable reality was the magic that happened when all three pillars stood in perfect alignment. When your personal experience matched the collective story, and the world's operating system ran without a glitch. For most of human history, that alignment was our home. Alex gets into his car. He turns the key, and the engine starts on the first try, just like it has for the last 4 years. Another test passed. He joins the familiar river of commuters. His GPS, a small black rectangle of pure trust, confidently shows the route to his office. Arrival at 8:42 a.m. But then, for a single, jarring second, it flickers. The icon of his car leaps from the road and appears in the middle of a vast, blue, digital ocean. The synthesized voice stutters, stretching into an unnerving drone before the screen refreshes. His car is back on the road. The arrival time now reads 8:43 a.m. He blinks. A glitch. Satellite handover, maybe. He's heard of it. In his peripheral vision, a flicker of light in the sky, like heat shimmer on a cold day, catches his eye and is gone. He dismisses that, too. We are masters of dismissal, experts at filing away anything that threatens our predictable world. The radio mentions unusual solar flare activity. He nods to himself. See? An explanation. A neat, tidy box for the glitch in the system. He turns the volume up, letting the news anchor's voice wash over him, and sinks back into the comforting rhythm of the commute. The first tremor has passed, unnoticed. The coffee is still warm. The traffic is still humming its predictable song. For now, the unraveling. The office is another temple of predictability. The same fluorescent lights hum, the same keyboards click, the same faces offer the same morning greetings. The social scripts that lubricate our lives are still running smoothly. Alex settles at his desk, the strange commute already fading into his brain's junk folder. His day is laid out in neat, colored blocks on his calendar. Meetings, deadlines, lunch. A map of a stable day. But the map is not the territory. The unraveling begins not with a bang, but with a quiet failure of the invisible systems we've outsourced our trust to. Alex types an urgent email and attaches a large file. He hits send. 5 minutes later, his client calls. Did you send it? Alex says he did. The client says they never got it. He tries again. The email vanishes into the digital ether. No bounce back, no error message, just gone. A colleague 2 cubicles down complains her video conference is a nightmare. It's like they're in a time loop, she says, her voice a mix of frustration and unease. They keep asking the same question every 3 minutes. A subtle chill permeates the office, the cold dread of unreliability. In the break room, the usual chatter is strained. A conversation about last night's big game dissolves into a confused argument. Half the people remember one team winning. The other half remembers a completely different outcome, and they remember it with absolute certainty. They pull up the news on their phones, and the headlines themselves seem to flicker, showing one result, then another, before settling on a third, entirely different story. The shared narrative, that pillar of intersubjective stability, is starting to crack. What happens when we can't agree on what happened yesterday? The unease curdles into genuine alarm just before noon. The large TVs in the lobby, usually on a financial network, suddenly switch to a stark, blue screen. A moment later, a news anchor appears. Her face is pale, her expression grim. This isn't a polished broadcast. This is different. We're interrupting this program, she begins, her voice tight. Across the world, widespread and severe disruptions are being reported in all forms of digital communication and navigation. Air traffic control systems are experiencing unprecedented failures, leading to a worldwide grounding of all flights. But the anomalies are not confined to our technology. We are receiving thousands of reports of what are being described as mass visual distortions. The screen cuts to a panel of experts. A physicist, a sociologist, a neurologist. They all look as bewildered as the anchor. The physicist talks about solar radiation, but his words lack conviction. He's trying to fit an ocean of impossible data into the thimble of known science. The sociologist mentions mass hysteria, but she can't explain how it could be so widespread. These are people who dedicated their lives to a predictable universe, and the universe just changed the rules without telling them. Then comes the point of no return. The broadcast is itself interrupted. The screen goes black, then displays the seal of a global scientific consortium. A woman with tired eyes and a stark white lab coat appears. She isn't in a news studio. She's in a control room, surrounded by frantic activity. "My name is Dr. Aris Thorne," she says, her voice steady but laced with an exhaustion so profound it feels ancient. "I am speaking on behalf of the Global Consortium for Foundational Physics. For the past 12 hours, our monitoring stations have been registering a cascading series of deviations. These are not equipment malfunctions. They are not the result of any known terrestrial or astrophysical phenomena." She pauses. The entire world holds its breath. "The constants are not constant," she says, and the words hang in the air, simple and world-shattering. "The foundational laws that govern our reality appear to be in a state of flux. We are not experiencing a systems collapse. We are experiencing a reality decoherence. We don't have an explanation. We don't have a projection. All we can confirm is that the world you knew this morning is no longer the world that exists right now. We advise everyone to stay where you are. To be with people you know. The operating system of the universe is being rewritten. We don't know what will come after the reboot." The screen goes dead. In the office, there is total silence. The clicking of keyboards has stopped. The argument about the game, the vanished email, the flickering GPS. It all snaps into a new, terrifying focus. These weren't glitches. They were symptoms. The illusion of normalcy, the comforting lie that held society together for millennia, has been irrevocably shattered. The map was wrong because the territory itself was dissolving. Alex looks at the colored blocks on his calendar. A perfect plan for a day that no longer existed, and with a single, numb click, he closes the window. The final hours. The end of the workday isn't announced, it just happens. A collective, unspoken consensus ripples through the office. The deadlines, the projects, the quarterly reports, all of it is suddenly absurd. What's a spreadsheet worth when physical constants are in a state of flux? People begin to stand up, first one, then a dozen, then everyone. They gather their things. A photo of a child, a favorite mug, the keys to a life that's losing its context. They file out into the hallway, leaving the temples of commerce to the ghosts of a bygone era. Alex's journey home is a descent into a soft, quiet chaos. The intricate dance of traffic has broken down. The rules of the road, another shared agreement, have evaporated. Some cars are abandoned, others crawl along, their drivers staring out with vacant expressions. But there's no honking, no road rage. The panic is too deep for that, too existential. It's a heavy, silent dread that has settled over the city like a blanket of ash. People are walking on the highways, their faces turned to the sky, searching for answers in the strange, shimmering air. Priorities have been brutally simplified. The complex web of ambition and obligation has been incinerated. All that remains is a single, primal imperative: get to your loved ones. Alex's only thought is of his wife, of his home, the one small anchor he hopes can still hold against this tide. His phone, once a connection to the entire world, is now a lifeline to a single person. He dials. The call connects, but it's a battle against a storm of static and strange, melodic interference. "Alex?" Her voice comes through, fragmented. "I'm on my way," he shouts over the noise. "Are you okay?" "The power's out," she says. "The sky." "Alex, the sky is the wrong color." The call drops. But it was enough. The connection was made. In the face of the universe unraveling, hearing her voice becomes the most important event of the day. It's a retreat to the first and last pillar of reality, the raw feeling of human connection. The world might be breaking, but the feeling of love, of responsibility, is still real. For now, when he finally reaches his street, the transformation is profound. The sun is setting, but it's a sunset unlike any he's ever seen. The colors are lurid and wrong. Deep violets bleed into sickly greens, and the light itself seems thick, almost viscous. The power grid is dead. Houses are dark, save for the flickering of candles. He finds his wife in the living room. They don't speak at first. They just hold each other, a desperate, silent confirmation that they are both still here, still solid. The final hours of stable reality aren't marked by screaming or explosions. They're marked by a deep, pervasive, and terrifying quiet. It's the quiet of a world holding its breath. They sit by the window and watch the old world die. It's not a sudden cataclysm, but a slow, poetic decay. A glass of water, knocked from a table, hangs in the air for 2 full seconds before dropping with a soft, muffled thud, as if the concept of brittle was being edited out of existence. Alex looks at their shadows on the wall. They aren't still. They stretch and writhe, separating from their bodies before snapping back. The butterfly effect made visible. Tiny deviations in the universal code are snowballing into impossibilities right before their eyes. The feeling that psychologists call derealization is no longer a symptom of trauma. It is now the objective condition of all humanity. The world doesn't just feel fake, it is actively demonstrating its own artifice. They look up at the night sky. The final, undeniable proof. The constellations are gone. Orion, the Big Dipper, the North Star, all wiped clean from the celestial slate. In their place are alien geometries, clusters of stars burning with colors the human eye was never meant to see. Some are moving in sharp, angular paths, like insects flitting across the black. In these final moments, the mundane routines they once found so dull feel like a lost paradise. The boring commute, the pointless meeting, the reliable sunrise, they were all part of a beautiful, unspoken pact with the universe. A pact that guaranteed a world that made sense. Now, there are no guarantees. The last anchor is the warmth of a hand held in the dark. It is the only truth left. They sit together in the encroaching strangeness, watching the last vestiges of their reality fray and dissolve into a new and unknown pattern. Conclusion. A sun rises. It is a pale, sickly yellow, and to the west, where the sun should not be, a smaller, dimmer orb of magenta light pulses faintly. The quiet promise that tomorrow would be much like today has been broken. The sky is a canvas of impossible colors. The air hums with a low frequency you feel in your bones. The old world is just a memory. Stable reality is a closed chapter in a book that's been thrown into the fire. We built our lives, our civilizations, our very sanity on a foundation of predictability we never thought to inspect. We trusted the ground beneath our feet without ever questioning what it was made of. It was a blind, beautiful faith in a world that, for a time, was steady enough to bear our weight. But the ground is gone now. The rules have been erased. And a new, unstable dawn is breaking. What do you build when the ground itself has dissolved into the air? What would you have done on your final day of stable reality? When all the routines and distractions fell away, what, or who, would have been the most important thing? Let us know your thoughts in the comments below. The day reality unraveled. Reality feels solid. You know, rock solid. You drop a ball, it hits the ground. Every single time. The sun rises in the east, sets in the west. It's a clockwork certainty you can plan your life around. The universe, it seems, plays by the rules. But what if all that is just an illusion? What if the entire universe, every star, every world, every single atom in your body, is hanging by a set of invisible threads? Threads made of numbers. Numbers so exquisitely precise, so mind-bogglingly fine-tuned, that if just one of them were to twitch by the smallest fraction, everything we know would simply stop existing. Today, we're not just going to look at those threads. We're going to imagine what happens on the day one of them snaps. What's stopping the universe from dissolving into a meaningless soup of static? What holds back the chaos? The answer is a hidden set of rules, a collection of cosmic dials that have been set to values of almost unbelievable precision. These are the fundamental constants of nature. Think of them as the universe's source code. Just like a programmer needs perfectly written code for an application to run, The universe needed a very specific set of numbers to boot up a reality that could support stars, galaxies, and eventually, us. And these aren't just abstract ideas, they're measured, established facts of physics that define the fabric of our world. Depending on how you count, there are about 26 of these numbers in the standard model of physics and cosmology, and they govern everything. The speed of light, the strength of gravity, the charge of an electron. These are the rules of the game. But here's the unsettling part. Nobody knows why these dials are set where they are. They seem completely arbitrary. Yet, if you were to reach out and nudge one, even by a hair's breadth, the consequences would be catastrophic. Not just for us, but for any chance of complexity, anywhere in the cosmos. So for the next few minutes, we're taking a journey to the very edge of existence. We'll explore the most critical of these cosmic numbers, witness the terrifying knife edge on which our reality is balanced, and confront the uncomfortable question of what, or who, set those dials in the first place. And then we'll ask the scariest question of all. Are these constants really constant? Stick around, because you'll never look at the solid world around you the same way again. The illusion of permanence. Every morning, you wake up and maybe you make a cup of coffee. You trust that the water will boil, that sugar will dissolve, that your mug won't suddenly disintegrate in your hand. You trust all this because you've seen it a million times. The laws of physics are reliable, permanent. Yesterday, today, and tomorrow, gravity is going to keep your feet planted on the ground. This consistency is the bedrock of our sanity. It's the foundation for our entire lives, and for all of science. For centuries, this was the core assumption of physics. Since Newton, we've believed the rules of the cosmos are universal and unchanging. An apple falls from a tree for the same reason a planet orbits a star. Light from a galaxy billions of light years away plays by the same rules of electromagnetism as the lamp on your desk. This idea, that the laws of physics are the same everywhere and for all time, is what allows us to study the universe at all. It's a pretty fundamental assumption. But what are these laws, really? At their heart, they're mathematical relationships. And buried in these equations are a handful of very special numbers. These are the fundamental physical constants. They aren't derived from some deeper theory. They're just measured values that we have to plug into our equations to make them work. So let's meet a few of the main characters in our cosmic drama. First up, the speed of light, c. It's the ultimate speed limit. Nothing with mass can reach it, and light itself can't go any slower. It weaves space and time together and, through Einstein's famous E=mc², it's the key that unlocks the incredible energy stored in matter. Next, the gravitational constant, g. This number sets the strength of gravity, the force that pulls everything together. It's the grand architect of the cosmos, building planets, stars, and galaxies. And even though it feels strong to us, on the cosmic scale, gravity is shockingly weak compared to the other forces. A fact that's going to be very important later. Then there's Planck's constant, h. This is the number that rules the wonderfully bizarre world of quantum mechanics. It defines the smallest possible chunk, or quantum, of energy, and tells us that at the tiniest scales, reality is pixelated. It's the reason atoms are stable and don't just blink out of existence. And there are others, lots of others. The mass of the electron, the strengths of the forces holding atoms together, the density of dark energy. All told, this couple of dozen numbers or so make up the control panel for our universe. They are the source code of reality. For our universe to look the way it does, for stars to shine, for planets to form, for chemistry to work, every single one of these numbers had to land in an incredibly narrow, life-permitting range. This is what physicists call the fine-tuning problem. It's not a problem like an error, but a deep, unsettling mystery. It's the observation that our universe seems perfectly, almost impossibly, balanced for life. It's as if we're all walking a tightrope across a cosmic abyss, where the slightest breeze could send us tumbling into nothing. The stability we take for granted, that feeling of solid ground, might just be a statistical miracle of unimaginable proportions. Now, let's get a closer look at that tightrope. The cosmic knife edge. To really get a feel for how fragile our existence is, we have to look at the cold, hard numbers. We're going to run through 3 of the most stunning examples of fine-tuning. These aren't just thought experiments, they're the direct consequences of the physics that makes our world tick. So brace yourself, because this is where reality starts to feel less like a rock and more like a winning lottery ticket. Our first stop is a number called the fine structure constant, or alpha. This constant is the king of chemistry and matter. It sets the strength of the electromagnetic force. Why is that a big deal? Because electromagnetism is responsible for basically everything you see and touch. It's the force that binds electrons to atoms, and the force that lets atoms link up to make molecules, the building blocks of rocks, water, and DNA. It's how light interacts with matter. Basically, if this force wasn't exactly as it is, there'd be no stable matter. No chemistry, no biology, no stars, no planets, and no you. The value of alpha is about 1/137. It's a pure number, meaning it's the same no matter what units you use. Physicists have long been obsessed with why it's 1/137th. But the asterisk y is less important right now than the asterisk what if. Imagine we have a cosmic dial that controls alpha. Let's turn it up, just a little. If electromagnetism were a few percent stronger, electrons would get sucked into the nucleus. Atoms would collapse. On top of that, the repulsion between protons in an atom's core would become so strong that you couldn't build big atoms. The universe would be stuck with just hydrogen. No carbon, no oxygen, no complexity. Okay, let's turn the dial the other way. What if alpha were weaker? Electrons would be held so loosely that the complex chemical bonds needed for things like DNA would just fall apart. Water wouldn't be a liquid. But the problem starts way before that. The fusion engines inside stars that cook up heavy elements are incredibly sensitive to alpha. A weaker force, and stars might not even switch on. Or if they did, they'd fail to create the carbon and oxygen that life needs. The window for a universe that can do anything interesting is terrifyingly small. 1/137th isn't just a good setting, it seems to be one of the asterisk-only settings that works. But if you think that's a close shave, our next example is where the numbers get truly insane. Let's talk about the cosmological constant, lambda. This number represents the energy density of empty space itself, what we now call dark energy. It's a gentle, persistent push that's making the expansion of the universe speed up. For most of the 20th century, physicists figured this number was 0. Then, in 1998, they discovered the universe's expansion is accelerating, which meant the constant had a tiny, positive value. And when I say tiny, I mean tiny on a scale that breaks the human brain. Quantum physics predicts a value for this constant. The problem is, that prediction is wrong. Staggeringly wrong. The predicted value is about 10 to the power of 120 times bigger than what we actually measure. That's a 1 with 120 zeros after it. This has been called the worst theoretical prediction in the history of physics. It means that for our universe to exist, some unknown cosmic effect is canceling out the predicted value with a precision of 120 decimal places. To put that in perspective, imagine trying to find one specific, marked atom from all the atoms in the entire observable universe. Your odds would be better than getting the cosmological constant to be this value by chance. What if it were different? If lambda were much larger, the repulsive force of dark energy would have been so powerful it would have ripped everything apart right after the Big Bang. No galaxies, no stars, no planets. Just a cold, expanding void of lonely particles. The Big Rip. And if lambda were negative and equally large, it would have added to gravity's pull. The universe would have expanded for a moment and then immediately collapsed back on itself in a big crunch. Not nearly enough time for stars to form, let alone for life to show up. Our universe exists on a razor's edge between those two disasters. A value tuned to 120 decimal places to allow for a gentle, steady expansion over billions of years. Finally, let's look at the building blocks of matter itself. The standard model of particle physics has a whole zoo of particles, and their masses seem to have no rhyme or reason. Yet they are just as finely tuned. Take the proton and the electron. A proton is about 1,836 times more massive than an electron. Change that ratio just a little bit, and you mess up the delicate balance needed for stars to fuse elements. Or look at the up and down quarks that make protons and neutrons. A neutron is a tiny fraction heavier than a proton. That tiny difference is everything. It makes free neutrons unstable, while protons are stable. If the masses were tweaked just slightly the other way, protons would be unstable and decay. In that universe, soon after the Big Bang, all protons would have turned into neutrons. No hydrogen, no stars, no water, no chemistry. Just a cosmos full of dead neutrons. The physicist Martin Rees wrote a book called Just 6 Numbers, highlighting a handful of these critical constants. Tweak any one of them, and you get a sterile, dead universe. It's a cosmic house of cards. Every single card has to be perfectly placed, or the whole thing comes tumbling down. The feeling of a robust, solid reality is just that, a feeling. We're living in an extraordinarily fine-tuned, and deeply improbable, cosmos. Which leads to the biggest question of all. Why? The unsettling explanations. So, here we are. In a universe that seems balanced on a pinhead. A cosmos where the rules look like they were tailored, against all odds, to allow for stars, planets, and us. How do you explain that? This question pushes us right to the edge of science, to the border where physics meets philosophy. There are a few main contenders, and every one of them is as mind-bending as the last. The first idea is the anthropic principle, usually paired with the multiverse. It's a wild, but elegant solution. It goes like this. What if our universe isn't the only one? What if there's a huge, maybe infinite, collection of other universes out there, and in each one, the cosmic dials are set to different values? Think of it like a giant cosmic lottery. A new universe is born for every possible combination of these constants. Nearly all of them are duds. Dead on arrival. In one, gravity is too strong, and it collapses in a microsecond. In another, electromagnetism is too weak, and it's just a cold soup of drifting particles. Countless universes exist, but they're sterile and empty, with no one inside to wonder why. But in this infinite sea of duds, just by pure chance, a tiny fraction will have the right settings. A universe with stable stars, with chemistry, with planets, with the potential for life. And, of course, we find ourselves in one of those universes for one very simple reason. We couldn't exist anywhere else. This is the anthropic argument. The laws of nature have to be compatible with conscious observers, because if they weren't, there'd be no one around to observe them. It gets rid of the fine-tuning mystery by saying we just won the cosmic lottery, and the proof is that we're here to talk about it. For a lot of physicists, this is the most scientific explanation. But to others, it feels like a philosophical cop-out. It's not really an explanation, just a resignation that it had to be this way for us to be here. That brings us to the second, and much older, explanation: intelligent design. The argument is pretty straightforward. If you're walking on a beach and find a watch, you don't assume the wind and waves randomly assembled it. You assume a watchmaker. The fine-tuning argument is the ultimate version of this logic. The universe is infinitely more complex and fine-tuned than a watch. The precision of the cosmological constant, 1 part in 10 to the 120, is so absurd that chalking it up to dumb luck sounds, to many, like an act of faith in itself. So, they argue, it's more logical to assume the dials were deliberately set by a tuner, a creator, a designer, a god. This isn't a scientific theory, because you can't test or falsify the existence of a designer. It's a metaphysical conclusion drawn from the scientific facts. It suggests our existence isn't an accident, but a feature. Of course, this just kicks the can down the road. Who designed the designer? It solves one mystery only to create an even bigger one. The third possibility is a modern, high-tech twist on the designer idea. The simulation hypothesis. What if our entire reality is just a computer program? In that scenario, the fundamental constants aren't mysterious laws of nature. They're just variables in the code. Parameters the programmers, whoever they are, typed in when they hit run. This would explain the fine-tuning perfectly. The values weren't a cosmic accident, they were chosen. Maybe the simulators wanted to see if they could create a universe that would evolve conscious beings like us. The laws feel arbitrary because they are arbitrary, chosen by an intelligence outside our system. The biggest problem here? There's no way to prove or disprove it from the inside. Any evidence we find could just be part of the program. It's a fascinating, but maybe unsolvable, rabbit hole. Finally, there's the explanation many physicists are banking on: unknown physics. Maybe our understanding is just incomplete. Maybe there's a deeper, more fundamental theory, a theory of everything, that will one day show us why the constants have to have the values they do. In this view, their values aren't random at all. They are mathematically inevitable, locked into place by a physical principle we just haven't discovered yet. If that's true, it means there's only one way the universe could be. The problem vanishes, explained away by better science. Physicists are working hard on this, with ideas like M-theory and loop quantum gravity. But so far, no theory has come close to predicting these numbers from scratch. The hope is there, but for now, the mystery remains. The big question. So, we're left with these profound, unsettling options. An infinite cosmic lottery, a deliberate designer, a computer simulation, or a law of nature we have yet to find. Each one completely changes what it means to be human. Which one makes the most sense to you? The cold, statistical logic of the multiverse? The purpose-driven idea of a designer? The sci-fi concept of a simulation? Or just plain faith in future scientific discovery? Let me know your thoughts in the comments. It's a discussion worth having. The climax, the day reality unravels. So far, we've been working on one huge assumption. An idea so basic we almost forget it's an assumption at all. That even though the constants are mysterious, they are at least constant. Fixed. Set in stone for all time. But what if they're not? This is where the real existential dread kicks in. What if the fine-tuning wasn't a one-time thing at the Big Bang? What if the dials aren't locked, but can slowly drift? Or worse, what if one of them could suddenly snap to a new setting? This isn't just wild speculation. Some advanced physics, like certain flavors of string theory, actually predict that the constants we see might not be truly fundamental. They could be tied to other, shifting fields or even the size of hidden dimensions. If those things change, the constants we rely on would change right along with them. For years, scientists have been hunting for any evidence of this. They've used light from distant quasars as a sort of cosmic time capsule. Since that light has been traveling for billions of years, it can tell us if a constant like alpha was different in the ancient past. For a long time, the answer seemed to be no. But recently, some tantalizing and very controversial hints have appeared. A few studies, looking at different parts of the sky, suggest alpha might have been slightly different billions of years ago. These results are at the absolute limit of our instruments and are hotly debated. Other observations, including recent ones from the James Webb Space Telescope, are being used to probe the constants in the early universe with even greater precision. While most studies still show no change, the fact that scientists are looking, and the results are a little fuzzy, means the door isn't completely closed. Even dark energy might not be constant. Some recent data from projects like the Dark Energy Survey suggests it might be evolving over time. So let's play this out. Let's imagine it happens. The day reality unravels. It wouldn't be a big, fiery explosion. It would be something much quieter and much more final. Imagine you're looking up at the night sky. The stars are scattered across the darkness, familiar and timeless. And then, in an instant, they're gone. They don't explode. They don't fade. They just wink out of existence. All of them. At once. What happened? The constant that governs the nuclear force inside stars just drifted. It shifted by less than 1%. But that was enough. The delicate balance for stellar fusion was broken. Across the entire universe, the engines of every star sputtered and died. The light stopped, and a permanent darkness fell across the cosmos. Or imagine a different scenario. The fine structure constant, alpha, the one holding your atoms together, suddenly changes. There's no warning, no sound, no feeling of dread. One moment, you are a complex collection of trillions upon trillions of atoms, held together by the electromagnetic force. The next moment, that force is a little weaker. The bonds holding the molecules in your body together simply dissolve. The electrons in your atoms are no longer tethered. You don't feel pain. You don't scream. You don't even have time to realize something is wrong. You, and the chair you're sitting on, and the building around you, and the planet beneath your feet, simply unravel. You disassemble into a cloud of unbound particles. A puff of chaotic, meaningless dust. It's not death. It's erasure. The file being deleted. A fatal error in reality's source code. This is the ultimate horror. The thought that the very rules of existence are not guaranteed. That the stability we depend on is a temporary gift, not a permanent right. The invisible threads holding our universe together could be fraying. We assume they'll hold forever, because they have for the 13.8 billion years we can look back on. But in a potentially infinite future, forever is a long, long time. We've journeyed to the bedrock of reality and found not solid ground, but a breathtakingly fragile balancing act. Our universe seems to be suspended on a web of impossibly fine-tuned numbers. Change the strength of gravity, stars burn out too fast. Tweak the mass of an electron, chemistry falls apart. Adjust the energy of empty space, and the universe either rips itself to shreds or collapses into nothing. We're left with a profound mystery. Is our life-giving universe one winning ticket in a multiverse lottery? Is it the work of a cosmic designer? Or is it a sign that we're still just at the beginning of our quest to understand the true laws of nature? And most chillingly, we face the possibility that this delicate balance isn't permanent. That the constants might not be constant, and that the fabric of reality itself could change in a flash. It's a humbling, maybe even terrifying, thought. But it's also a powerful one. It gives our existence a sense of profound wonder. The fact that you're here, that you can think, that you can even ask these questions, is a testament to an extraordinary and fragile stability. Every sunrise, every breath, every moment you get to experience is a gift from a universe that happened to get its recipe just right. The solid ground beneath your feet may be an illusion, and reality may be hanging by a thread. But for now, that thread holds. And in this precious, stable moment in cosmic history, we have the incredible privilege of being here to witness it all. The day the Mandela effect became real. We place an enormous amount of trust in our memory. It's the foundation of our identity, the record of our lives. But what happens when that foundation shows cracks? Not just for one person, but for millions, all at once. What happens when a shared memory, vivid and certain, turns out to be false? This is a journey into a modern phenomenon known as the Mandela effect. It begins not with monsters or myths, but with the quiet, unsettling realization that the world we remember may not be the world that is. For years, we've treated these inconsistencies as simple quirks of the mind, amusing trivia about a children's book or a line from a movie. But what if they were something more? What if we were to view them not as mistakes in our brains, but as the first tremors of a deeper instability? This is an exploration of that possibility. We'll examine the known facts of this psychological puzzle, and then we will travel further, into a thought experiment. A world where the Mandela effect stops being a trick of the mind and becomes physically real. The anatomy of a false memory. The phenomenon gets its name from a discovery made around 2009 by a woman named Fiona Broome, a self-described paranormal researcher. She found that she and a large number of other people shared a very specific and detailed memory, that the South African leader Nelson Mandela had died in prison during the 1980s. They recalled news clips of his funeral and speeches from his widow. The key problem, of course, is that this never happened. Nelson Mandela was released from prison, later became president of South Africa, and passed away in 2013. But this shared, incorrect memory was so widespread that Broome gave it a name. Once named, the floodgates opened. People began identifying hundreds of these collective misrememberings, many tied to the pop culture that formed the wallpaper of our lives. One of the most famous examples is the children's book series, The Berenstain Bears. Millions would insist the name was spelled with an E, Berenstain. It feels more natural, but every official book cover reads Berenstain with an A. The real spelling often looks alien, an imposter on the bookshelf of our youth. This extends to some of our most quoted movie lines. In *The Empire Strikes Back, Darth Vader's famous reveal is almost universally remembered as, "Luke, I am your father." Yet, the actual line is, "No, I am your father." The name, Luke, is never spoken in that line. In Disney's Snow White *, the evil queen never says, "Mirror, mirror, on the wall." The line is, "Magic mirror on the wall." The effect is also visual. Consider the mascot for the board game Monopoly, Rich Uncle Pennybags. In the collective mind's eye, he is often pictured with a monocle. It fits his aesthetic as a wealthy caricature. And yet, he has never had one. Similarly, many remember the Fruit of the Loom logo featuring a cornucopia, a horn of plenty, behind the fruit. It was never there. Perhaps one of the strangest cases is a movie that seems to exist only in memory. A significant number of people who grew up in the 1990s have detailed recollections of a comedy called Shazam, starring the comedian Sinbad as a genie. They can describe the poster and the plot. The only issue is that this movie does not exist and was never made. People are likely conflating it with the movie Kazam, which starred Shaquille O'Neal, but the memory of Shazam is remarkably persistent. For years, the scientific explanation for these phenomena has been logical and well established. Psychologists point to concepts like confabulation, where our brain fills in memory gaps with fabricated details that it then accepts as true. They also use schema theory, which suggests we misremember details to better fit our pre-existing mental frameworks. Of course, a character named Pennybags would have a monocle, as it fits the rich old man schema. A 2022 study from the University of Chicago scientifically documented this visual Mandela effect, confirming how consistent these false memories for icons are. In the internet age, these shared errors can spread and reinforce each other, a process known as suggestibility. This was a psychological phenomenon, a quirk of our fascinatingly flawed gray matter. And this is where the story should end. But now, let's take a step beyond the established science, into a speculative world where these glitches are no longer confined to the mind. A speculative escalation. Let's imagine a world where the line between a memory problem and a reality problem begins to dissolve. In this thought experiment, the glitches become physical. Picture a subtle lag in physics. You walk down the street, and for a split second, your shadow hesitates before catching up, like a moment of lag in the world's code. You might try to film it, but the effect would be too subtle, easily dismissed as a camera's frame rate issue. It would be a personal, unnerving reminder that the rules are becoming suggestions. What makes this hypothetical scenario especially interesting is how it moves from the abstract to the tangible. Consider what some have called object replication. A set of keys you drop into a bowl is joined by an identical copy the next morning, complete with the same unique scratches and wear. A single sock enters the laundry and emerges with a twin. It's as if the universe is accidentally copying and pasting assets where they don't belong. Then, one could imagine causal slips. A coffee mug slips from your grasp, and time seems to stretch as you watch it fall. But instead of shattering, it hangs in the air for a moment before reversing its trajectory, flying back into your hand. An outside observer would see only a clumsy fumble and a quick recovery. You, however, would have witnessed a localized violation of gravity. This is the key problem. If reality glitched, but only for you, how would you prove it? The world's placid insistence that everything is fine would become the most isolating force imaginable. In such a world, people might turn to history to find precedent, re-examining old urban legends. Stories like the time slips on Bold Street in Liverpool, where people reported momentarily walking from the modern day into the 1950s, would no longer seem like mere folklore. They would be viewed as early data points. People might begin to notice small gaps in their own days, looking at a clock at 3 p.m., blinking, and seeing it read 3:17 p.m., with no memory of the intervening time. The psychological toll of living in a world with holes in it would be immense. The fracture point. In our hypothetical world, what happens when a glitch is no longer personal or subjective? What happens when it's public, physical, and permanent? Imagine a major city square, home to a landmark statue that has stood for a century, a bronze general on a horse, for instance. One morning, the general is gone. In its place, on the same granite plinth, stands a completely different statue made of weathered white marble. There's no sign of construction. The new statue looks as if it has been there for 100 years. The real paradox would be the human reaction. Most people would walk by without noticing a thing. If you were to ask them about the old statue, they would look at you with genuine confusion. In their memory, the marble statue has always been there. Their personal and cultural history has been seamlessly rewritten. But a scattered few would remember. They would stand there, staring in shock, their memories now out of sync with the world. The internet would become a battleground for reality. People who remembered the old landmark would post old photographs as proof. But then, a new, more terrifying phase would begin. The evidence itself would start to change. A digital photo of the bronze general would flicker and resolve into the marble statue. The change would ripple backward through time, consuming the past to protect the integrity of the new present. At this juncture, the term Mandela effect would no longer suffice. It would be clear that this isn't about memory. You cannot confabulate a 10-ton block of marble into existence. Psychology cannot explain digital photos editing themselves in real time. This would be the fracture point, where the world is demonstrably overwritten, and memory becomes the only fossil record of a lost timeline. The unraveling. Following a public fracture, our speculative world would descend into a kind of surreal chaos. These revisions would become more common. Strange phenomena, once isolated, would become global. Imagine the entire pigeon population in a major city square freezing mid-flight, hanging motionless for minutes before resuming their course as if nothing happened. Picture a new, uncharted island suddenly appearing on all satellite imagery and nautical charts, its geology and flora following bizarre, non-Euclidean rules. The glitches would become more intimate. People might experience what they call echo people, strangers on the street unconsciously mirroring their unique gestures moments after they make them. Or they might experience auditory previews, faintly hearing the words of a person nearby just a second before they are spoken aloud. In this scenario, our established sciences would be in disarray. Geologists couldn't explain the new island, and physicists couldn't explain the frozen birds. In this vacuum, theories once relegated to the fringe would enter the mainstream. One would be simulation theory. The idea that our reality is a computer program, and we are experiencing bugs in the code. The changing statues are asset swaps. The duplicate keys are copy-paste errors. Our memories of the old world are merely data left in the cache. The other major theory would be rooted in quantum mechanics, the many worlds interpretation. This theory suggests that infinite parallel universes exist and that the walls between them are becoming porous. Elements are bleeding through from other timelines where the Berenstain Bears are spelled with an E, and a different statue has always been in the square. Our reality isn't breaking down, it's converging with others. Conclusion: a world in a constant state of chaos cannot last. Human beings possess a remarkable capacity for adaptation. Eventually, the unraveling would slow, giving way to a new normal. The glitches would not stop, they would simply become a part of life. Time slips might become a standard excuse for being late. People might carry duplicates of important items as a practical measure against random replication. It's interesting to consider how society would contort itself to fit these new rules. Architecture might change to account for objects and people phasing through walls. Children born into this world would have no concept of a stable reality. To them, the idea of a world where the past is fixed and shadows always obey their owners would seem like a fantasy. The ones who remember the world before would be a dying breed, living relics of a lost timeline. The journey of the Mandela effect, from a quirk of memory to this speculative unraveling, serves as a powerful reminder. It shows how our perception of a solid, stable reality is built on the foundation of our minds. The original Mandela effect was never about a glitch in the world, it was a demonstration of the glitches within us. It revealed that our collective memory, the first system to show these strange signs of failure, is far more fluid and mysterious than we ever believed. It forces us to confront an interesting question. If our perception can be so easily and collectively altered, what does that tell us about the nature of reality itself? Why your world suddenly feels so fragile? There is a perception, one that has become increasingly common, that the systems underpinning modern life are growing less stable. It can be observed in reports of unprecedented weather events, in the persistent tensions of global politics, or in the unexpected scarcity of a product on a supermarket shelf. This sense that predictability is waning is not an abstract anxiety. It appears to be a rational observation of a world undergoing fundamental, and perhaps irreversible, change. For much of modern history, human societies have operated on an unspoken assumption of stability. The expectation was that economies would generally expand, the seasons would follow a familiar rhythm, and progress, while not always linear, was the general direction of travel. This assumption allowed for long-term planning, the construction of complex global networks, and a belief in a certain kind of permanence. But what happens if this foundational assumption no longer holds? What if we have, without marking a specific moment, crossed a threshold into a new state? This is an exploration of that crossing. It is an examination of how the complex, seemingly resilient systems of the 20th century have become more brittle. We appear to be living in the shadow of tipping points, some of which may have already been passed. The era of perceived stability has shifted, and an era of systemic fragility is emerging. Understanding this shift is critical for navigating what comes next. This is not a narrative of doom, but one of clarity. By analyzing the nature of this new fragility, we can better understand how to operate within it. This analysis will explore the moment we began to pass these thresholds, why our world feels precarious, and what it means to live in the aftermath. A world built on unseen guarantees. To understand the fragility of the present, we must first remember the stability that preceded it. The latter half of the 20th century, while not a period of universal peace or prosperity, was defined by a historically unusual degree of predictability. Following the Second World War, a new global order emerged. Its architecture, for all its flaws, was designed to promote stability. Institutions like the United Nations, the World Bank, and the International Monetary Fund were established to manage global affairs and prevent the kind of systemic collapses seen in prior decades. The global economy, governed by the Bretton Woods Agreement, was anchored to a system of fixed exchange rates, which created a reliable environment for international trade. The Green Revolution in agriculture promised to meet the demands of a growing population. Global supply chains began to lengthen, weaving the world into an intricate network of production and consumption, all built on the idea that goods could move freely and predictably across borders. A just-in-time world was constructed, a model of efficiency that assumed geopolitical calm and open ports. This human-made stability was mirrored by a much deeper guarantee. For approximately 12,000 years, a geological epoch known as the Holocene, human civilization benefited from an extraordinarily stable climate. The global average temperature hovered near 14 degrees Celsius, with fluctuations rarely exceeding half a degree. This consistency was the silent partner in humanity's development. It was the predictable backdrop against which agriculture was developed and cities were built. The regular rhythm of the seasons and the predictable patterns of rainfall were not merely pleasant features. They were the fundamental operating system for complex societies. This stability became a baseline expectation. It was so constant that it was forgotten as a condition, and mistaken for a certainty. Economic models were built on the assumption of continuous growth. Carbon was released into the atmosphere, and for a time, the Earth's large, resilient systems, its oceans, forests, and atmosphere, acted as a buffer, absorbing the impact and masking the true cost of these activities. This era created a psychological expectation of permanence. The belief that this is simply how the world functions became encoded in insurance policies, infrastructure planning, and financial markets. It was largely forgotten that our globalized civilization was built on a specific and benevolent natural foundation. For decades, we have been methodically altering that foundation. The fragility we perceive today is the dawning recognition that this foundation is showing cracks, and the guarantees are no longer unconditional. The first crack, the climate system's warning shot. The first and most profound cracks have appeared in the Earth's climate system. For decades, scientists described climate change in the future tense. We are now living in the present tense of their models. The planetary systems that once absorbed our impact are now buckling. The core concept to understand here is the tipping point. Imagine a system that appears stable as it absorbs stress until a final addition causes a sudden, nonlinear cascade. The system has fundamentally changed its state. The Earth's climate is an interconnected network of major systems, and for over a century, we have been adding stress to all of them. For some of these systems, the state change has begun. One of the most visible examples is the ongoing degradation of warm water coral reefs. These ecosystems support an estimated 25% of all marine life and provide food and livelihoods for hundreds of millions of people. They are, in effect, the rainforests of the sea, and they are dying. Recent record-breaking ocean heat has triggered mass bleaching events on an unprecedented scale. Since 2023, analyses indicate that around 60 to 70% of the world's coral reefs have experienced the kind of heat stress that leads to bleaching. Bleaching occurs when coral expels the algae that provided with food. It is not instant death. If the water cools, the algae can return. However, the cool La Niña phases that historically gave reefs time to recover are becoming shorter and less effective, while the warm El Niño phases grow more intense. We are moving from a state where bleaching was a rare, localized shock to one where it is a frequent, global event, making recovery increasingly difficult. While some reefs show resilience, particularly when local pressures like pollution are reduced, the overall system has lost its former stability. We are witnessing a biome-level system pass a critical threshold in real time. The corals are an early indicator. Other, larger systems are also showing clear signs of instability. Consider the Atlantic Meridional Overturning Circulation, or AMOC. This is a vast system of ocean currents that functions as a planetary-scaled conveyor belt, transporting warm water from the tropics to the North Atlantic and driving climate stability in the Northern Hemisphere. Research shows the AMOC has weakened by about 15% since the mid-20th century, a slowdown that appears to be unprecedented in over 1,000 years. This is linked to the influx of cold, fresh water from Greenland's melting ice sheet, which disrupts the balance of temperature and salinity that powers the current. The scientific consensus, including the IPCC, views a full collapse this century as a low likelihood, high-impact event, though some newer, debated models suggest it could happen sooner. The consequences would be severe, altering weather patterns that billions of people rely upon. The risk is no longer theoretical, the system is becoming measurably more fragile. Then there is the Amazon rainforest. This ecosystem generates much of its own rainfall, creating flying rivers of moisture that influence weather across the continent. Scientists have long warned of a tipping point, often estimated to be around 20 to 25% deforestation, where the forest might transition into a drier, savanna-like state. As of early 2026, cumulative deforestation stands at approximately 17 to 18%. While the exact threshold is still debated, severe droughts and fires in recent years mean that large parts of the southeastern Amazon are already emitting more carbon than they absorb. The process of savannification appears to have begun in some fringe areas. These are not isolated issues. A key concern is the risk of a tipping cascade. The melting of Greenland's ice weakens the AMOC. A weaker AMOC can alter weather patterns over South America, putting more stress on the Amazon. A dying Amazon would release vast stores of carbon, further accelerating global warming, which in turn melts more ice. The systems that once maintained equilibrium now risk pulling each other down. This process has been accelerated by record temperatures. The year 2024 was the warmest on record, at about 1.55 degrees Celsius above pre-industrial levels. While 2025 was slightly cooler, it was still among the top 3 warmest years. This contributed to the first-ever 3-year period where the average global temperature exceeded the 1.5 degrees Celsius benchmark that the Paris Agreement was designed to avoid. The climate system appears to have lost its capacity to quietly absorb pressure. It is now responding with greater force and unpredictability. The second crack, the economic system's brittle bones. As the Earth's natural systems showed visible cracks, so did the human-made systems built upon them. The global economy, the web of finance, production, and trade, has also entered an era of fragility. In the late 20th century, the global economy often seemed destined for perpetual growth, with recessions viewed as minor corrections. The 2008 financial crisis was different. It was a profound systemic shock, revealing that the complexity built for efficiency had also created hidden fragility. The illusion of a stable, self-regulating market was fractured. The response to that crisis laid the groundwork for a new form of fragility. To prevent a global depression, central banks engaged in an unprecedented experiment: quantitative easing. They injected trillions of dollars into the financial system and pushed interest rates to near zero. This created an economy that ran less on productive growth and more on inexpensive debt. We now live with the consequences. As of early 2026, global government debt is projected to be around $105 trillion, which is approximately 95 to 100% of the world's GDP. High levels of debt reduce an economy's capacity to invest in the future or respond to the next shock, whether it is a pandemic, a war, or a climate disaster. The system becomes more brittle. This underlying fragility was exposed by the COVID-19 pandemic. The pandemic did not break the global supply chain, it revealed its inherent inflexibility. For decades, operations had been optimized for cost, with the just-in-time manufacturing model as its pinnacle. This hyper-efficient system was designed with no slack or redundancy. When the pandemic hit, it seized up. In the years since, these disruptions have become a more permanent feature of the landscape. The era of smooth globalization is giving way to an age of geo-economic confrontation, where nations use economic tools like tariffs and sanctions as strategic instruments. Companies are now shifting from just-in-time to just-in-case strategies, building redundancy and diversifying suppliers. This makes supply chains more resilient but also more expensive, contributing to inflationary pressures. The reliability of global trade is no longer a given, but a risk to be managed. This economic fragility is intertwined with climate fragility. Our economic system was built on cheap, abundant fossil fuels. Today, that energy foundation is the primary driver of climate instability. This presents a paradox. The energy source that powered our growth is now making our world less stable. The necessary transition away from it is, itself, a source of immense economic and geopolitical volatility. The global economy today still functions, but its underlying structure is weighed down by debt, fractured by geopolitical rivalries, and subject to supply disruptions. Like the climate, it has lost much of its resilience and its capacity to absorb shocks. The tipping point moment, the day the rules changed. There was no single day when the world crossed from stability to fragility. It was a confluence of events, a period from the late 2010s to the mid-2020s, where accumulated stresses appeared to breach the limits of our global systems. This was the moment the asterisk illusion of stability shattered. The COVID-19 pandemic revealed the brittleness of the just-in-time world. The subsequent war in Ukraine exposed the fragility of energy and food systems. The record-shattering heat and climate disasters of 2024 and 2025 were the Earth's definitive statement that the stability of the Holocene was over. Layered together, these events created the pervasive sense of precariousness we began with. They were the symptoms of a world that had changed. This is where the narrative shifts. At the same moment these negative tipping points began to cascade, a series of positive tipping points were also triggered. We are not just passively observing systemic breakdown, we are actively building a new system. The central tension of our time is this race between breakdown and transformation. For the first time since the Industrial Revolution, global greenhouse gas emissions are at or near their peak and may have already begun to decline. The International Energy Agency projects that renewables are on track to surpass coal as the planet's largest source of electricity by mid-2026. This is happening primarily because of economics. In most parts of the world, building new solar and wind farms is now cheaper than running existing fossil fuel plants. This has triggered a positive cascade. In 2025 alone, global investment in clean energy technologies reached an estimated $2.2 trillion. The growth of solar and wind is now described by analysts as irreversible. Technologies like electric vehicles and battery storage have crossed their own tipping points in leading markets, moving from niche products to mainstream technologies with self-sustaining adoption. This is the true state of our world in 2026. It is as if we are standing in two different canoes, each moving in a different direction. One canoe holds the negative tipping points, the degrading coral reefs, the weakening ocean currents, and the risk of cascading environmental collapse. The other canoe holds the positive tipping points, the exponential growth of renewable energy and the rapid technological innovation that offers a path away from the crisis. The fragility we feel is the tension of being stretched between these two realities. The rules of the stable, forgiving Holocene world are gone. Stability is no longer a given, it is something that must be actively created and maintained. Living in the approximation, a guide to the new reality. How does one operate in this new world? The world is not ending, but the world as we knew it, the predictable, stable world of the 20th century, has ended. We now live in what could be described as a fragile approximation of the systems we once relied on. The climate system still works, but it now delivers a baseline of normality punctuated by bouts of unprecedented extremity. The global economy still works, but it no longer reliably delivers stable growth, lurching between threats of recession and inflation. The greatest mistake would be to assume the goal is to restore things to the way they were. The spilled water cannot be put back in the glass. The path forward is not restoration, but adaptation. And the first step in adaptation appears to be a psychological shift. This involves moving from anxiety to awareness. The feeling of fragility is a signal, a perception of the new reality. To acknowledge this allows one to stop expending energy on a world that no longer exists and instead invest it in building a life suited to the world that does. This clarity is a form of power. The second step is to translate that awareness into action. In a fragile world, local actions become more significant. If global supply chains are brittle, then strengthening local and regional networks for food, energy, and goods is a logical response. This is not about lone survivalism, but about rebuilding community, supporting local businesses, and creating networks of mutual aid. Decentralized systems, like rooftop solar connected to a neighborhood microgrid, are inherently more resilient than centralized ones with single points of failure. A food system based on a diversity of local farms is more resilient than one reliant on monoculture crops shipped from across the globe. In an age of global fragility, resilience is often built from the ground up. Finally, we must learn to embrace the race. The knowledge that we are living between negative and positive tipping points can be galvanizing. It means our choices, both individual and collective, have never been more consequential. In the old, stable world, individual actions could feel insignificant. In a system poised at a tipping point, a small push can matter more. Every decision, to consume less, to support a clean energy initiative, to vote for policies that accelerate the green transition, is a push on the right side of the scale. We are among the first generations to be faced with this particular challenge, armed with the scientific knowledge of the systems we are breaking, and in possession of the technological tools to build an alternative. Living in this fragile approximation of the world is not a curse. It is an invitation to be more mindful, intentional, and connected. The fragility of the system demands a new strength, one based not on the illusion of permanence, but on the power of adaptation, awareness, and conscious choice. Conclusion. The perception of fragility, then, appears to be a rational response to observable changes in our core global systems. We have left the calm harbor of the Holocene and entered the turbulent waters of the Anthropocene, an era defined by the consequences of our own actions. The systems that governed our lives have lost much of their built-in resilience. But this new fragility does not have to be a sentence of despair. It can be a catalyst. It compels an awakening from the dream of infinite growth and a recognition of the intricate connections between our economy and our planet. The fragility is a mirror, and in it, we can see the immense power we now wield. We are living in a moment of profound consequence, a race between the world we are breaking and the world we could build. The outcome is not yet written. The future is not a thing to be discovered, but a thing to be created. What aspect of this fragile world concerns you the most? And where do you see the most hope for building resilience? Let us know your thoughts in the comments. And for more explorations into our changing world, consider subscribing. The computer glitch that proved the future is unpredictable. In the winter of 1961, in a quiet office at the Massachusetts Institute of Technology, a scientist named Edward Lorenz watched a machine print a line of numbers. It was a primitive computer, programmed to simulate the weather, and what it was showing him seemed like a mistake. He had run 2 simulations, one meant to be a direct continuation of the other. He expected them to be identical, but they were not. One set of numbers described a calm, predictable weather pattern. The other, starting from what should have been the same point, described something else entirely, a system that had evolved into a completely different future. Lorenz's first thought was that the machine had failed. A faulty wire, a broken vacuum tube. But the computer was working perfectly. What he was seeing, in the 2 different paths spelled out on paper, was something else. It was a quiet glimpse into a fundamental truth about our world. That it is balanced on an edge so fine that the smallest, most imperceptible event, a rounding error of less than 1 part in 1,000, could grow and ripple outward until it changed the future. This was not the failure of a machine. It was the beginning of a new understanding of the world itself. The idea of a clockwork world. For centuries, science had been shaped by a comforting and elegant idea, the dream of a predictable universe. The person who gave us this dream, more than anyone, was Sir Isaac Newton. His Principia Mathematica, published in 1687, offered laws of motion and gravity that were powerful and deterministic. They suggested that if you knew the forces acting on something, you could calculate its future with perfect accuracy. Suddenly, the universe felt less like a place of mystery and more like a grand, intricate machine. It had rules. The planets moved in knowable orbits. Objects moved in predictable arcs. And if the universe followed rules, then its future was not a mystery to be divined, but a problem to be solved. This idea reached its fullest expression in the early 19th century with the French mathematician Pierre-Simon Laplace. He proposed a thought experiment involving a vast intellect, a consciousness that could know the exact position and momentum of every atom in the universe at a single moment. For this intellect, which came to be known as Laplace's demon, the future would hold no secrets. Given the initial state of everything and Newton's laws, it could calculate the entire trajectory of the cosmos, from the beginning of time to the end. For such an intellect, Laplace wrote, nothing would be uncertain in the future, just like the past, would be present before its eyes. This was the quiet promise of classical science. A future that was already written, locked into place by the present. Randomness was just a word for our own lack of knowledge. If we could only measure things precisely enough, we could predict anything. The idea of total knowledge, of absolute certainty, felt like it was within reach. But even inside this clockwork cosmos, small questions were beginning to emerge. The first person to really look into them was another French mathematician, Henri Poincaré, working near the end of the 19th century. He was studying the three-body problem. Newton had solved the motion of 2 bodies orbiting each other, but adding a third body, like the moon to the Earth and Sun, made the mathematics explode in complexity. While working with these equations, Poincaré found something subtle and unsettling. He saw that in some cases, a very small change in the starting position of one body could lead to a dramatically different orbit later on. He was the first to realize that a system could be perfectly deterministic, obeying all the known laws, and still be practically unpredictable. The problem, he saw, was our inability to ever know the starting conditions with infinite precision. Poincaré had noticed a quiet strangeness hiding within Newton's orderly universe. But his discovery remained a mathematical curiosity, confined to the world of celestial mechanics. It would take another 70 years, and a new kind of machine, to show that this strangeness was not a special case. It was everywhere, and the man who would find it was not looking for it at all. He was just trying to forecast the weather. The man and the machine. Edward Lorenz was a quiet, thoughtful man. Born in Connecticut in 1917, He was a mathematician who became a meteorologist during World War II. After the war, he settled at MIT, dedicating himself to the study of the atmosphere. He was an avid hiker and lover of the outdoors, and he felt a personal connection to the complex, flowing patterns of the weather he studied. He believed that the atmosphere, for all its complexity, must obey the laws of physics. Prediction should be possible. His laboratory in 1961 was built around this belief. It was centered on a Royal McBee LGP30 computer. By modern standards, it was a simple machine, the size of a large desk, humming with vacuum tubes and relays. But at the time, it was a portal to a new way of doing science. For the first time, a scientist could create a simplified, virtual world, a toy universe, and watch it evolve according to mathematical rules. Lorenz's toy universe was a model of the Earth's atmosphere, simplified down to just 12 equations. These equations represented things like temperature, pressure, and wind speed. He would give the computer a set of starting numbers and let the machine work, calculating how they would change over time. Every minute or so, the printer would type out a new line of numbers, a snapshot of his artificial weather. One day, Lorenz wanted to look more closely at a weather sequence the machine had already generated. To save time, he decided to start the simulation from the middle. He took the printout from the previous run and carefully typed the numbers for an intermediate point back into the machine. He started the program and went to get a cup of coffee, letting the machine do its work. When he returned an hour later, he looked at the new printout. He expected to see a perfect copy of the original run. The numbers, after all, were meant to follow the same rules from the same starting point. Instead, he saw something that puzzled him. For the first few simulated days, the two printouts were a perfect match. But then, a tiny difference appeared. The numbers began to drift apart, slowly at first, then more and more. He watched as the two streams of data, which had started almost identically, diverged onto completely different paths. One printout was describing fair weather. The other was describing a total collapse of that pattern, a descent into a virtual storm. His first thought was that the machine had malfunctioned. He checked the hardware. Everything was working correctly. He ran the program again. The same thing happened. The machine wasn't broken. Confused, Lorenz looked for the source of the difference. He compared the numbers he had typed in with the original numbers from the first run. And then he found it. The difference was almost invisible. To save space on the paper, the printer was programmed to show numbers rounded to 3 decimal places. So a value like 0.506127 was printed as 0.506. But inside the computer's memory, the full, 6-digit number was stored. When Lorenz restarted his simulation, he had used the shortened, 3-digit number, 0.506. The original run had started from the more precise value, 0.506127. The difference between them was just 0.000127. In the orderly world of classical science, such a tiny change should have been meaningless. It should have caused a small, temporary wobble in the output that would quickly fade away. But it hadn't faded away. It had grown. The tiny initial difference had been amplified by the system's equations, doubling and redoubling until it had completely changed the outcome. The sunny day had become a storm. Staring at the two pieces of paper, Lorenz realized he was seeing a fundamental property of the world. The glitch was not in the machine. The quiet realization. In that quiet MIT office, something shifted. The initial confusion gave way to a deep realization. It was not a mistake, it was a discovery. He was seeing, for the first time, a fundamental property of complex systems. He gave it a name: sensitive dependence on initial conditions. What this meant was both simple and profound. In systems like the weather, tiny, imperceptible differences in the starting point don't just stay tiny. They feed back into the system, growing exponentially over time until they produce completely different outcomes. It's like a tiny pebble rolling down a mountainside. Near the top, a push of a millimeter to one side is almost unnoticeable. But by the time it reaches the bottom, that millimeter has determined whether it ends up on the left side of a valley or the right. Lorentz had found that the atmosphere was just like that mountainside. Its future was exquisitely sensitive to its past. This created a deep problem for prediction. To perfectly predict the future of such a system, you would need to know its starting conditions with infinite precision. Not near perfect precision, infinite. If your measurement of the temperature is off by a millionth of a degree, your forecast will eventually be wrong. The error, no matter how small, will grow until it contaminates the entire prediction. Since it is physically impossible to measure anything with infinite accuracy, Lorentz concluded that long-term weather forecasting was not just difficult, but fundamentally impossible. A decade later, in 1972, a colleague suggested a more poetic title for a talk Lorentz was giving. Predictability. Does the flap of a butterfly's wings in Brazil set off a tornado in Texas? The phrase, the butterfly effect, was born. The metaphor is often misunderstood. It doesn't mean a single butterfly is responsible for a specific tornado. The reality is more subtle. The atmosphere is a turbulent, swirling system. A tornado will form when conditions are right. The butterfly effect means that the system is so sensitive that something as small as the puff of air from a butterfly's wings can be the tiny nudge that alters the sequence of events, causing the tornado to form at a slightly different time, or in a slightly different place, or not at all. The real impossibility is that we can never know which tiny input will be the one that matters. The system is a cascade of consequences too vast and complex to trace. This was the core of what became known as chaos theory. And it held a quiet paradox. The systems were completely deterministic. They followed fixed, unchanging laws. There was no randomness involved. And yet, their long-term behavior was completely unpredictable. It was a new kind of principle, order that produces unpredictability. To better understand this, Lorentz simplified his model even further, down to just 3 equations. When he plotted the trajectory of this new system in 3-dimensional space, he saw an image of mesmerizing complexity begin to emerge. It was a continuous line that looped and swirled, never repeating itself and never intersecting. It looked remarkably like a pair of butterfly wings. This image became known as the Lorentz attractor. An attractor is a state that a system tends to evolve towards. But this was a strange attractor. It showed that even though the system's specific path was unpredictable, its overall behavior was confined to this beautiful, bounded space. It was a portrait of chaos itself, a system forever moving between order and randomness, freedom and constraint. It was a picture of a hidden structure governing the unpredictable. When his work was published in 1963, it went largely unnoticed. But slowly, scientists in other fields, studying population dynamics or market fluctuations or fluid turbulence, began to realize they were seeing the same patterns. The butterfly's shadow reached much further than anyone, even Lorentz, had imagined. It wasn't just about the weather. It was about everything. The butterfly's shadow. Lorentz's discovery was like a key that quietly unlocked different doors. Scientists began to see sensitive dependence on initial conditions everywhere. It was a universal principle, governing not just abstract models, but the world around us. Consider the evening of November 9, 1989, at the Berlin Wall. A mid-level East German politician named Günter Schabowski held a press conference. The government had drafted new, relaxed travel regulations, but they weren't meant to take effect until the next day. Schabowski had been handed the note just before the conference and hadn't read it carefully. Near the end, a reporter asked when the new rules would apply. Schabowski, unprepared, shuffled his papers and said, "As far as I know, immediately, without delay." It was a mistake. A small deviation from the plan. But it was broadcast live. East Berliners began to gather at the checkpoints. The border guards had no orders. Faced with a growing, joyous crowd, and without instructions, one officer finally gave the order: open the gate. A system that had been held in rigid stability for decades was undone by one person's fumbled sentence. Just 6 years earlier, another man's quiet hesitation had a very different outcome. On September 26, 1983, Lieutenant Colonel Stanislav Petrov was the duty officer in a Soviet nuclear early warning bunker. Shortly after midnight, sirens went off. A screen flashed the word, "Launch." The system was reporting that 5 missiles had been launched from the United States. His protocol was to immediately relay the warning, which would have triggered a retaliatory strike. But he paused. Something felt wrong. His intuition told him it was a false alarm. A real attack would be massive, not just 5 missiles. He made a decision. He reported a system malfunction. He was right. The satellites had mistaken the reflection of sunlight off high-altitude clouds for missile engines. A rare atmospheric alignment, a tiny flicker of light, had almost started a global thermonuclear war. The world continued, unaware, because one person paused when the system demanded action. The butterfly effect is not always about such high-stakes moments. Sometimes, its consequences are quiet and life-giving. In 1928, the bacteriologist Alexander Fleming returned to his lab after a vacation. He noticed one of his petri dishes, where he had been growing bacteria, was contaminated with mold. His experiment was ruined. But then he looked closer. In the area around the mold, the deadly bacteria had been dissolved. Instead of throwing it away, his curiosity was piqued. He isolated the mold and discovered the antibiotic agent it produced. That moment of accidental contamination, a random spore drifting through a window, led to the development of penicillin, a medicine that has saved millions of lives. Once you begin to look, you see these dynamics in many places. The sudden crashes of the stock market are not entirely random. They are often the result of feedback loops, where small inputs of fear or greed can cascade into market-wide panic. A smooth-flowing highway can become a traffic jam because one driver brakes a little too hard, creating a shockwave that moves backward through the line of cars. Each is a system where the future is held hostage by the smallest of details. A new kind of universe. The discovery of chaos did more than change science. It invited a new way of looking at the world. The clockwork dream of Newton and Laplace was a worldview that offered a sense of order. It promised a world where everything was, in principle, knowable. Chaos theory suggested something different. The key distinction was between asterisk determinism and predictability. Before, these two ideas were seen as the same. If a system was deterministic, its future was predictable. What Lorentz showed is that this is not true. A system can be completely governed by fixed laws, yet still be unpredictable in practice. Laplace's demon might still be a theoretical possibility, but he would need to know the starting state of the universe with an impossible, infinite precision. The dream of absolute prediction was replaced by something more subtle. We live in a world of laws, but we are surrounded by uncertainty. This quietly brings up one of the oldest questions. What does this mean for free will? The debate was often stuck between two ideas. In a clockwork universe, our choices can feel like illusions, the predetermined result of a machine set in motion long ago. But if our actions are just the result of pure randomness, they don't feel like our choices either. Chaos theory offers a third, more nuanced space. It doesn't prove free will, but it provides a framework where our choices can be meaningful without being rigidly pre-written. Our brains are incredibly complex, nonlinear systems. A choice is an emergent property of this vast network. Because the system is chaotic, its state is exquisitely sensitive to input, to our experiences, our memories, our deliberations. This allows our actions to be determined by us asterisk, by the sum of who we are in a moment, without being predetermined from the beginning of time or being merely random. More importantly, it suggests a profound and quiet significance to our actions. If a butterfly's wing can alter the weather, what can a single act of kindness do? What are the cascading effects of a thoughtless word or a moment of courage? We can never know. The future is not a destination we are traveling to, but a landscape we are helping to create. The computer glitch that puzzled Edward Lorenz was, in the end, a gift. It replaced the idea of a sterile, clockwork universe with something more interesting, a universe of infinite complexity and quiet creativity. It revealed a reality that is not a finished script, but a story being written, moment by unpredictable moment. That quiet failure in Lorenz's printout is a gentle reminder that our world is fragile, interconnected, and balanced on the delicate wings of a butterfly. The story of chaos theory shows how one person's curiosity about a small puzzle can change our understanding of the world. If this kind of calm exploration into the ideas that shape our world helps you unwind, consider liking the video and subscribing to the channel. I'm always curious to hear your thoughts. Does this idea of a chaotic, unpredictable universe feel liberating or unsettling? Feel free to share in the comments below. Conclusion. In the end, the glitch was a revelation. It taught us that the world is not a problem to be solved, but a beautiful, intricate pattern that is constantly evolving. It showed us that predictability is the exception, not the rule, and that uncertainty is a fundamental part of our existence, not just a limit of our knowledge. Edward Lorenz passed away in 2008, having lived to see his quiet discovery grow into a new branch of science. He left us with a universe that is more intricate, more mysterious, and far more interesting than the one we thought we knew. A universe where the smallest of things can matter most, and where the future, wonderfully, is always waiting to be written. Why you won't notice when reality collapses. In early 2018, a strange thing started happening across Europe. People with simple electric clocks, the ones on their ovens, microwaves, or bedside alarms, began noticing they were running late. Not by seconds, but by minutes. By March, the collective lag had stretched to almost 6 minutes. Now, this wasn't some coordinated prank or a solar flare messing with the grid. For nearly 2 months, the shared, mechanical measurement of time seemed to be stumbling. The problem was eventually traced back to an incredibly tiny deviation in the continent's interconnected power grid. The standard 50 Hz frequency, the invisible electrical pulse that keeps everything in sync, had dropped to an average of 49.996 Hz. A practically infinitesimal error. And the cause? A political dispute between Serbia and Kosovo, hundreds of miles away, which led to a small but constant power deficit. A distant crack in a political system sent a physical ripple across a system so vast that for weeks, almost no one saw that a fundamental rhythm of daily life was slowly breaking down. This story isn't really about clocks. It's a perfect metaphor for a much larger, and frankly, more unsettling idea. That the end of reality as we know it won't be a spectacular explosion. It won't be some dramatic event you can circle on a calendar. It'll be a quiet, uneven decay. A slow unraveling that starts with cracks so small they are, for all intents and purposes, invisible. It will be a cascade of tiny errors in systems we completely take for granted. And the most disturbing part? Our own brains, the very tools we use to perceive reality, are exquisitely wired to help us ignore every single sign. This is the story of the quietest apocalypse. So if reality started to fray tomorrow, would you even notice? The cracks in the facade, the slow collapse of worlds. When we think of collapse, our minds go to the movies. Cities on fire, asteroids from the sky, zombies at the door. But history and science tell a very different story. The most profound collapses aren't sudden events, they're slow motion processes of disintegration. A long decay, where the things that hold a world together erode from the inside out, long before anyone notices the building is starting to tilt. Let's start with us. With civilizations, we have this romantic idea of great empires falling in a blaze of glory, a single, decisive battle, a barbarian horde at the gates. But that's almost never how it actually works. Take the Roman Empire. Its fall wasn't a single day in 476 AD. It was a slow rot that went on for centuries. The symptoms were subtle at first and spread unevenly. While the city of Rome was still a glittering metropolis, the foundations of its power were quietly crumbling. Soil erosion crippled its agricultural base. Generations of currency debasement, shaving a bit of silver off a coin here, mixing in cheaper metals there, unleashed runaway inflation that hollowed out the economy. The incredible aqueducts and roads, those marvels of Roman engineering, started to fail from a simple lack of maintenance. Small breaks went unfixed. Supply lines got a little less reliable. These weren't dramatic disasters. They were the boring, mundane failures of a system that had just gotten too complex to manage. Sure, history points to plagues and invasions, but those were often just the final, brutal symptoms of a disease that had been progressing for generations. The body was already sick. The external shocks just sped up the inevitable. This isn't just a pattern in ancient history. It's a recurring theme that has been put under a mathematical microscope by a field called cliodynamics, pioneered by researcher Peter Turchin. Turchin treats history like a massive dataset, looking for repeating patterns that can predict periods of instability. One of his most powerful concepts is something called elite overproduction. It works like this. Every society has a certain number of elite positions, in government, business, law. For a society to be stable, you need a rough balance between the number of people who want those jobs and the number of jobs available. But what happens after a long period of peace and prosperity? The population grows. More people get wealthy, more people get educated, and they all, quite reasonably, believe they deserve a spot at the top. The number of elite aspirants starts to swell, far outpacing the number of actual elite roles. You end up with thousands of ambitious, highly educated people fighting for a few hundred prestigious spots. A whole generation is promised a seat at the table, only to find the dining room is already full. This creates a growing class of frustrated, resentful, and very capable people. They become counter-elites. They have the resources and the motivation to challenge the existing power structure, which fragments the whole political landscape. At the same time, this is usually happening alongside a wealth pump, economic systems that funnel wealth from the general population to the very, very top. So for most people, wages stagnate while life gets more expensive. The result is a perfect storm. A feuding, divided elite, and an impoverished, angry populace. Sound familiar? Turchin's models, developed years ago, actually pointed to the 2020s as a period of peak instability in the West, based on these long-term trends. This isn't prophecy, it's pattern recognition. It's the societal version of watching tiny, almost invisible stress fractures form in a bridge. The collapse doesn't happen the day the first crack appears. It happens when enough cracks have built up that the structure can no longer bear its own weight. And this erosion is happening on an even more fundamental level. Think about the very glue that holds a modern society together: trust. For decades, we trusted our institutions. We trusted the government to generally have our back, the news to report facts, and the economy to offer a fair shot. That bedrock is turning to sand. Data from organizations like the Pew Research Center shows a steady, decades-long collapse in public trust. In the late 1950s, about 73% of Americans said they trusted the federal government to do the right thing most of the time. Today, that number has cratered. For the last 15 years, it has rarely broken 30% and has recently hovered near historic lows, sometimes below 20%. And this isn't just one party or the other. The overall trend for both sides is a steep, undeniable nosedive. This erosion of trust is a form of societal collapse, happening in slow motion. When we no longer share a common set of facts or a belief in the systems that govern us, we fragment. We retreat into our own tribes, each with its own version of reality. The political polarization and rampant misinformation we see everywhere aren't the cause of the breakdown, they're the symptoms of it. They're the audible groaning of a social structure that is quietly, but relentlessly, pulling itself apart. The glitches in the code when the laws of physics fray. If societal collapse feels a little too close to home, let's zoom out. Way out, beyond our planet, to the very fabric of reality itself. Because here too, the ultimate end probably isn't a bang, but a slow, quiet, and almost imperceptible process. Physicists have a concept that is both beautiful and absolutely terrifying: false vacuum decay. Imagine the universe is resting in a valley. Our universe, with its specific laws of physics, the strength of gravity, the speed of light, is comfortable. It feels permanent. But what if, just over the next mountain range, there's another, much deeper valley? A state of even lower energy, a true vacuum. If that's the case, our cozy home is a false vacuum. It's stable for now, but not fundamentally stable. And quantum mechanics says that, eventually, a piece of our universe could just tunnel through the mountain and fall into that deeper valley. If that happens, a bubble of true vacuum is born. Inside this bubble, the laws of physics are rewritten. Fundamental constants change. Atoms might not even be able to form. And this bubble would expand outwards in all directions at the speed of light, and anything it touches would be instantly and utterly erased. Okay, that sounds like the opposite of a slow collapse. So what do I mean? Because the birth of this bubble is a random, delicate process. For it to grow, the energy it gains by expanding has to be greater than the energy it costs to maintain its surface. Small bubbles are unstable, they tend to just fizzle out of existence. To become a universe ender, a bubble has to be born with just the right size, under just the right conditions, in one specific, lonely corner of the cosmos. A single bubble, expanding at the speed of light, might take billions of years to reach us. From our perspective, the universe would seem perfectly fine for eons. And then, without any warning, it wouldn't. We'd never see it coming. It's not an explosion that fills the sky, it's a silent, creeping wall of absolute nothingness. The collapse begins not when the bubble reaches us, but at the moment of its birth, billions of light years away. It's an uneven, patchy decay of reality itself. This idea of quiet, gradual change echoes down into the quantum world. The classic idea of quantum mechanics, the Copenhagen interpretation, involves an abrupt collapse. A particle exists in a fuzzy cloud of possibilities, a superposition, and the moment you measure it, snap, it collapses to a single, definite location. But newer theories are painting a much more subtle picture. Models of gradual collapse, some proposed by thinkers like Roger Penrose, suggest there is no sudden snap. Instead, it's a slow fade. The particle's superposition creates a tiny, conflicting warp in space-time, and gravity gently nudges it toward a single state, rather than forcing it. Interestingly, some of those older, instantaneous collapse models predicted a side effect: a faint, constant shower of X-rays from all the jittering particles. But we've looked, and we've found nothing. The profound silence of the universe is actually a powerful piece of evidence that reality prefers to resolve its ambiguities quietly. And this leads to an even weirder idea, where physics and information collide. What if the most fundamental thing in the universe isn't matter or energy, but information? The universe is constantly writing its own history into its fabric. This accumulation of information is what gives time its arrow. You can't unscramble an egg because the information of it's scrambled. state is now hopelessly complex and spread out. If reality is a structure of information, then collapse is a form of information overload. And it brings us to a mind-bending analogy from the world of 2D materials, the hexatic phase. When you melt a normal crystal, it goes straight from a solid, a perfect grid of atoms, to a liquid, a completely disordered soup. It's a clean break. But in 2 dimensions, something weirder happens. As you heat a 2D crystal, it first enters an intermediate state, the hexatic phase. In this state, the atoms lose their perfect positions, they can slide around like a liquid. But they keep a kind of orientational order. The bonds between them still tend to point in the same few directions. It's a state that is neither solid nor liquid. It's a mushy, half-melted state of pre-collapse. A crystal that flows. The hexatic phase is the perfect metaphor for the collapse of reality. It shows that systems don't have to break all at once. They can lose one kind of order while clinging to another. Reality can become a slush, a flowing mess that still holds the ghost of its former structure. The transition from order to chaos isn't a switch. It's a phase. A long, strange period where the old rules get fuzzy. The blind spot, why your brain won't see it. So, we've got cracks forming in society and the laws of physics themselves seem to allow for a gradual, silent end. But why don't we see it? Why isn't everyone panicking? The answer is both simple and deeply unsettling. Our brains evolved to survive the savannah, not to comprehend the slow collapse of complex systems. We are masters of dealing with immediate, tangible threats. The predator in the grass, the sudden storm. But those same survival tools become profound blind spots when we're faced with slow-burning, abstract dangers. This isn't a personal failing, it's a feature of human psychology. It's a collection of cognitive biases, and the most powerful one is normalcy bias. Normalcy bias is the little voice in your head that insists the world as it is today will be the world as it is tomorrow. In a disaster, it's what makes people watch floodwaters rise and delay evacuation, thinking, it's never gotten this high before, it'll be fine. Studies of human behavior in catastrophes are shocking. They've found that in many disasters, up to 80% of people show signs of normalcy bias. They freeze, they rationalize, instead of acting. We are just hardwired to believe the future will look like the recent past. This is especially true for threats that build slowly. A rustle in the bushes gets our immediate, undivided attention. The slow, incremental rise of the global temperature over decades? Not so much. It feels psychologically distant, not urgent. We are programmed to prioritize the urgent over the important. Then there's its cheerful cousin, optimism bias. This is the well-documented tendency for us to believe that we are less likely to experience negative events than other people. We all know it. The smoker who thinks they won't get cancer. The driver who thinks they're better than average. It's a useful bias, it gives us courage. But when applied to systemic risks, it's just another layer of denial. Yes, collapse is possible, but it won't happen to us. Yes, the economy is shaky, but I'll be okay. But here's the most mind-blowing one. Inattentional blindness. You may have heard of the invisible gorilla experiment. People are asked to watch a video and count how many times a team in white shirts passes a basketball. It takes focus. Halfway through, a person in a full gorilla costume walks into the middle of the frame, thumps their chest, and walks off. When asked afterward if they saw anything unusual, about half the people report seeing nothing. Their brains, so focused on counting passes, literally did not process the image of a gorilla standing right in front of them. This is a profound metaphor for our situation. We're all intensely focused on our own basketball game, our jobs, our families, our daily lives. And while we're busy counting the passes, the slow, lumbering gorilla of systemic collapse can walk right through the middle of our lives, and half of us won't even see it. Finally, even if we push past all of that and see the crack in reality, we run into the wall of cognitive dissonance. This is the mental stress we feel when we hold two conflicting beliefs. Believing the world is stable and receiving information that the world is fragile creates that stress. To resolve it, you can either change your core belief, which is terrifying, or you can reject the new information. The easier path is almost always to dismiss the evidence. That's just fear-mongering. That can't be true. So you've got this fortress of denial built into your own head. Normalcy bias tells you nothing will change. Optimism bias says even if it does, you'll be fine. Inattentional blindness stops you from even seeing the evidence. And cognitive dissonance makes you actively fight against it if it slips through. Our brains are not windows onto reality. They are powerful filtering engines designed to build a simplified, useful model of the world. But when faced with complex, slow-moving threats, that filter becomes our greatest vulnerability. It ensures that when the real collapse comes, we might just be the last to know. Conclusion. The perception horizon. We started with a clock, a tiny gear stumbling almost invisibly. We've journeyed through the slow death of empires and peered into the heart of the cosmos, only to find that the universe itself may prefer a quiet unraveling over a final bang. And we've looked in the mirror and found that our own minds are designed to look the other way. What emerges is this idea of a perception horizon. Just like a black hole has an event horizon, a point of no return, a collapsing system seems to have a perception horizon. By the time the collapse becomes obvious, spectacular, and undeniable, it's already far too late. The critical moments happened long before, in the realm of the subtle and the unnoticed. Now, this can feel incredibly bleak. Like we're passengers in a car with blindfolds on. But maybe that's not the right way to look at it. The argument that reality collapses quietly isn't an argument for despair. It's an argument for a different kind of attention. It's a call to look past the noisy, immediate headlines and learn to see the patterns. It suggests that the most important work isn't building a bunker for some final, explosive day, but learning to see the cracks while they're still small enough to fix. Understanding our own cognitive biases is the most empowering step of all. Knowing you have a normalcy bias doesn't make it go away, but it gives you the power to question it. When your gut says, everything will be fine, you can learn to ask, but what if it isn't? What are the small signs I might be missing? Awareness is the antidote. Perhaps the true collapse isn't of society or physics. Perhaps the true collapse is the failure of our own perception. We are trying to navigate the 21st century with a brain that is, in many ways, still scanning the horizon for lions. The end of the world is not a destination. It's a process. And by seeing it as a process, we reclaim our agency. Noticing the cracks isn't an act of surrender, it is the first act of defiance. It's the beginning of understanding. And in that understanding, in the quiet, difficult act of paying attention, lies the chance to trace the fractures back to their source. The chance not just to watch the world unravel, but to begin, piece by piece, to weave it back together. So, the real question isn't whether reality will collapse. The question is, will we collapse our outdated ways of seeing it in time? Thank you for joining me on this journey. If this exploration of systems, perception, and collapse resonated with you, consider subscribing for more deep dives into the ideas that shape our world. The conversation doesn't end here. So, let me know your thoughts in the comments. What subtle cracks do you see forming in the world around you? And what, if anything, gives you a reason to hope? How the world secretly glitched to survive collapse. Have you ever had the quiet feeling that the world as we knew it should have fractured by now? But somehow, it didn't? Think about the last few decades. We've moved through a global pandemic that stilled our civilization, faced financial tremors that threatened to reshape economies, and navigated a chaotic tangle of supply chains that left shelves empty. It felt as if the very ground beneath our feet was trembling. We saw the warnings, we felt the instability. And yet, the systems held. The world, though strained and altered, kept moving. Many might see this as simple fortune, a near miss, a disaster narrowly avoided. But what if the real story is something quieter and far more peculiar? What if, to survive, our world underwent a series of strange, undocumented adaptations to its very operating principles? This is the quiet story of how our most foundational systems, healthcare, technology, and finance, didn't just withstand collapse. They didn't just build stronger defenses. They mutated. They bent their own rules, rewrote their own instructions in real time, and fundamentally altered their own form to continue functioning. This isn't a story of rigid strength. It's a story of strange, unprecedented, and sometimes imperfect adaptation. It's the story of how we quietly, and perhaps accidentally, adapted our way toward survival. The problem, the end of a stable era. To understand what occurred, we first have to appreciate the idea of the end of a stable era. It's not one single day. It's a turning point. It's that moment when the predictable world we were built for begins to change, when the systems we depend on, from the vast networks of global trade to the biological realities of our health, reach the limits of their design. It is the moment the old rulebook is set aside, not by choice, but because the environment itself has fundamentally changed. For generations, our world was constructed on an assumption of stability. We built hospitals assuming a predictable rhythm of patients. We designed financial models assuming a certain predictable human behavior. We laid down technological infrastructure assuming a steady, linear path of progress. These assumptions were like the climate of a long, stable epoch. They were the conditions we had adapted to, so constant that we forgot they were even there. Then, that climate began to shift. The 21st century has been a relentless series of environmental pressures. The 2008 financial crisis, the Syrian refugee crisis, the rise of disinformation, profound climate events, and then, the global pandemic. Each event on its own was a significant shock. But together, they created a cascade of instability, a storm that threatened to unravel the entire interconnected ecosystem. The foundational idea that was challenged was that our systems were like rigid, unchanging structures. We imagined them as concrete walls designed to hold back a flood. When the waters of crisis rose higher than ever before, we expected those walls to either hold firm or shatter completely. We were watching for the great rupture, the definitive moment of collapse. But that's not what happened. The walls didn't break. They became something else entirely. They became permeable, allowing some of the chaos through in a controlled manner, rather than letting pressure build until the entire structure failed. Instead of resisting the crisis, the systems began to adapt to it. Adaptation, in the quiet language of survival, is simply the process of changing to become better suited to a new environment. And our environment had become one of permanent, rolling change. This is the central curiosity. When faced with total, systemic pressure, our world's systems didn't respond with rigid denial. They performed a quiet, ingenious, and almost invisible maneuver. They glitched. They updated their own internal code, often in ways that went against their long-established functions. And in doing so, they carried us across the threshold. To see how, we need to look at the process itself. We need to examine these adaptations in our three most critical systems: healthcare, technology, and the intricate web of finance and infrastructure. The revelation, the adaptive mutation. The clearest way to understand this glitch is to think of our societal systems as complex organisms. Healthcare, finance, technology, they all operate on a set of core principles, a series of rules and inherited behaviors. If X happens, then do Y. Never permit Z. For decades, this programming worked. But when an unprecedented environmental pressure arrives, the existing programming has no response. The organism freezes. It faces extinction, unless it can adapt. In software, a hotfix is a rapid patch to fix a critical bug. It isn't always elegant, but it keeps the system running. What we have witnessed is the societal equivalent of a series of live, system-wide adaptations. Let's explore the first case study, the moment our biological reality itself was threatened. Case Study 1. The healthcare adaptation, a pandemic rewrites the rules. Before 2020, healthcare was a system defined by its deliberate, measured pace. It was powerful, but incredibly slow to change course. Developing a new drug could take a decade. Medical consultations happened in person. Hospital capacity was a carefully calculated, inflexible figure. This was the stable era. Then the virus arrived. It was a crisis that didn't just pressure the system, it rendered its entire operating manual obsolete overnight. The old rules, a new vaccine takes 10 years, hospitals operate as independent entities, patients must be seen in person, were now a path to failure. The system was headed for collapse. And then, it adapted. Consider the front lines at a place like Cleveland Clinic Abu Dhabi, which faced the pandemic early and intensely. Their carefully constructed plans and models didn't just bend, they were put aside. Travel restrictions meant they suddenly became the sole center in the nation for many critical procedures, all while facing an unknown, surging pathogen. This is the end of an era scenario. By the old rules, they should have been overwhelmed. They should have collapsed. But they didn't. They initiated a series of rapid adaptations. First, they recalibrated their measurements. The concept of bed capacity, once a fixed number, became fluid. They built screening tents outside the emergency department. They reconfigured entire sections of the hospital, creating a hospital within a hospital to isolate COVID patients and prevent internal spread. The very definition of what a hospital bed was and where it could be was rewritten in a matter of days, not decades. Second, they shifted their models of operation. The traditional model of a hospital as a solitary island of care was abandoned. Facing the crisis, they embraced a new, collaborative approach, partnering with their local ecosystem and the wider Cleveland Clinic network in ways that would have seemed unthinkable before. The model shifted from isolated work to a networked response, sharing burdens and knowledge to survive together. Finally, they adjusted their interpretation of old procedures. The rigid, top-down decision-making process was too slow. They had to empower innovators on the front lines. The old way was, follow the playbook. The new, adapted interpretation became, do what works, now. This meant embracing new technologies at an accelerated rate. A pre-pandemic digital strategy became the foundation for a massive, overnight change. They launched virtual visits, and within a month, 50% of their outpatient appointments had moved to remote platforms. This wasn't a planned, 5-year digital transformation. It was an emergency adaptation, installed directly into the heart of the system because the alternative was to let patients go without care. The story of vaccine development is the ultimate example. The old code said creating a vaccine was a linear, decade-long process. The mRNA vaccine adaptation turned it into a parallel, incredibly fast process. Bureaucratic steps once seen as essential were re-evaluated and streamlined for the emergency. Trial phases were run concurrently. Governments took enormous financial risks, pre-ordering millions of doses of vaccines that were still in development, a move that defied all traditional models of investment. This wasn't just working hard. This was a fundamental change in the source code of medical innovation and public health. The system didn't just resist the pandemic, it mutated alongside it. This strange, messy, unprecedented series of adaptations was what kept the system functioning. It was chaotic, but it was the only thing that worked. The tech adaptation, a change in form. The technology sector often presents itself as a world of sleek, intentional design. But it too has faced its own moments where its core assumptions were challenged, and survival depended on a radical, rule-bending adaptation. Let's go back to 2016. Samsung launched its flagship Galaxy Note 7. Within weeks, reports emerged of the device's overheating and catching fire. The product meant to be a crowning achievement became a global symbol of failure. The stable reality, for a corporation in this position, according to the old playbook, was to minimize and deflect. Admit a minor issue, blame a supplier, and hope the storm passes. We saw this initially. Samsung suggested it was an issue with third-party chargers and launched a limited replacement program. But then the replacement phones also began to catch fire. The old playbook was failing. A collapse in reputation and finance seemed imminent. So they adapted. They abandoned the old code of corporate defense and executed a system-wide change built on radical accountability. First, they adjusted their interpretation of the problem. It went from a minor battery issue to a total system failure of unknown origin. They stopped trying to control the story and instead embraced the uncertainty. This was a profound shift. They admitted they didn't know exactly what was wrong. A terrifying admission for a tech company, but the only authentic move left. Second, they recalibrated their measurements of risk. The old measurement was profit and market share. The new, adapted measurement was public safety and long-term trust. Based on this new metric, they made a decision that, by old standards, defied logic. They recalled every one of the 2.5 million devices shipped and permanently discontinued the product line, costing them an estimated $5 billion. Finally, they shifted their model from secrecy to transparency. Instead of hiding their investigation, they publicized it. They built a massive testing facility with 700 researchers to analyze 200,000 phones. They publicly released their findings, which showed 2 separate battery defects from 2 different suppliers. More importantly, they announced a new, industry-leading 8-point battery safety check for all future devices. This was the adaptation in action. Samsung didn't resist the story that their product had failed. They leaned into it, becoming the world's foremost experts on why their own product failed. In doing so, they changed the conversation from "Samsung makes flawed phones" to "Samsung is now a leader in battery safety." It was a difficult and expensive process, but it worked. They didn't just fix a product, they rewrote their corporate DNA. We saw a similar adaptation in 2020 with Zoom. As the pandemic began, Zoom went from a business tool to essential global infrastructure overnight. But this sudden growth exposed significant security and privacy flaws. The term Zoom bombing entered our vocabulary. Trust began to evaporate. The old tech playbook would be to issue quiet denials and hope the problem faded. Instead, Zoom's CEO, Eric Yuan, did something different. He issued a public apology and announced a complete 90-day freeze on new features. All engineering resources would shift to focus only on trust, safety, and privacy. This was another systemic adaptation. The core code of a fast-growing tech company is growth at all costs. Zoom deliberately stopped that process. They hired outside experts to publicly scrutinize them and held weekly public webinars to candidly discuss their failures and progress. Over 90 days, they rolled out more than 100 new safety features, including true end-to-end encryption. Like Samsung, Zoom didn't resist the crisis, it absorbed it. It used public failure as a catalyst for a forced, rapid evolution. It bent its own rules of growth to fix its foundation. This is the pattern. When the old rules lead to collapse, the only way to survive is to adapt. The societal adaptation, rewriting the social contract. Sometimes the adaptation is not just corporate, it is societal. It involves rewriting the implicit rules that govern trust between people and institutions. A legendary example of this happened long before the Internet age, but it provides a perfect blueprint for understanding the adaptations of today. The year is 1982. The company is Johnson & Johnson, and the product is Tylenol. At the time, Tylenol was one of the most successful over-the-counter products in the US, built on a foundation of consumer trust. Then, on September 29, that foundation vanished. In the Chicago area, 7 people died after taking Tylenol capsules that had been maliciously laced with cyanide. The social contract, that the products you buy from a trusted brand are safe, was broken. Johnson & Johnson found itself in an impossible position. The company was not legally at fault. A third party had committed a crime. The company's legal advisors could have argued to distance themselves and protect their bottom line. That was the standard procedure. But the company's chairman, James Burke, recognized that the old rules were obsolete. A legal win would be a total societal loss. He initiated an adaptation in the software of corporate responsibility. First, he recalibrated the measurement of success. The primary metric was no longer profit, it was public safety. Guided by the company's credo, which stated its first responsibility was to its customers, Burke ordered a nationwide recall of all Tylenol capsules, 31 million bottles, costing over $100 million. It was an unprecedented act. Second, he shifted the model of communication. Instead of hiding behind lawyers, Johnson & Johnson embraced total transparency. They established toll-free hotlines and held daily press briefings, turning the media from adversaries into partners in public safety. Finally, and most importantly, they adjusted their interpretation of the problem. The problem wasn't just a single criminal act. The problem was the vulnerability of the packaging itself. So, Johnson & Johnson didn't just bring back the old product. They invented the solution: a new, triple-sealed, tamper-resistant package. They didn't just solve their own crisis. They solved a crisis for the entire industry, setting a new global standard for safety that we all benefit from today. The result? Within a year, Tylenol had recaptured almost all of its lost market share. The brand became a legend in crisis management. This wasn't a PR campaign. It was a fundamental adaptation in the capitalist code. By prioritizing public trust over immediate profit, Johnson & Johnson rewrote the rules and, in doing so, secured its own future and fortified the social contract for everyone. This pattern, this willingness to abandon the old playbook when it no longer serves, is the quiet thread connecting these seemingly separate events. It is a form of systemic intelligence, a survival instinct embedded in our collective structures. And we can see it at an even larger scale when we look at our planet's infrastructure. The infrastructure adaptation, keeping power flowing. Our physical world runs on a similar set of assumptions. Power grids, for example, are built assuming a certain kind of climate. But what happens when the climate itself begins to change in unexpected ways? The summer of 2003 in Europe was a stark preview. A record-breaking heatwave led to an estimated 70,000 excess deaths. It was also an infrastructure crisis. In France, which relies on nuclear power, the heatwave presented a problem. Nuclear plants require vast amounts of river water for cooling. But as rivers warmed and water levels dropped, the plants faced a difficult choice: shut down and risk massive blackouts, or continue operating and release water back into the rivers that was hotter than environmental safety levels allowed. The system's rules were clear. The by-the-book response would have been to shut down the reactors. But this would have triggered a cascade of failures. The stable era had ended. The code was broken. So, the system adapted. Regulators flexed the emergency norms, an exceptional exemption was granted, allowing a number of reactors to continue functioning even as they exceeded the legal limits for cooling water temperature. This was a calculated choice. They recalibrated their measurements of risk, deciding that the immediate risk of a blackout during a lethal heatwave was greater than the short-term environmental risk. Furthermore, they adjusted their interpretation of safe operation. Instead of a simple on-off switch, plants derated their power, running at a reduced capacity to lessen the thermal load while still feeding the grid. It was a compromise, an adaptation in the manual. But it kept the lights on. This event was a quiet wake-up call. It revealed the fragility of infrastructure built for a climate that no longer existed. The response since has been a slow institutionalization of this adaptive philosophy. It proved that in a true crisis, the rules must become more fluid. You don't just build higher walls, you learn to navigate a new environment. From a hospital in Abu Dhabi to a boardroom in Seoul, from a communications team in New Jersey to a power grid regulator in Paris, the story is the same. When the pressure became too great, the systems didn't shatter. They adapted. They rewrote their own rules. They found a new form. And it is this ability to adapt that is so quietly fascinating. We spend so much time focusing on the fragility of our systems, and for good reason. But we rarely discuss their hidden flexibility. It raises a gentle question. Is this adaptive capacity something we can rely on? Or is it a finite resource we are using up with each new crisis? Thinking about systems, both large and small, is what we do here. If this kind of calm exploration of our world unwinds you, consider liking the video and subscribing to the channel. By supporting our sponsors, you help us continue to ask these kinds of questions. So thank you. Now, let's return to what it means to live in a world that has adapted. The implication: life in the adapted world. So, we survived. The adaptations were made. The system rebooted, a little different, a little stranger, but still running. But what does it mean to live in the aftermath? What are the consequences of adapting our reality in real time? Are we more resilient now, or have we simply exchanged one kind of fragility for another? The first implication is that normal as a fixed state is gone. The stable reality of the 20th century is a historical artifact. We now live in a world of constant, low-grade, rolling change. The adaptations that saved us, rapid vaccine development, emergency financial measures, radical corporate transparency, flexible infrastructure rules, are becoming permanent features of this new environment. Telemedicine is no longer an experiment, it's a fundamental part of healthcare. Corporate accountability is no longer just a strategy, it's a core expectation. Climate adaptation is no longer theoretical, it's an engineering necessity. This new normal has its benefits. Our systems are, in theory, more agile. We've demonstrated that we can innovate at incredible speed when necessary. We've learned that collaboration, even between rivals, is possible when facing a shared threat. We have a new set of tools, a new playbook for when crisis strikes. We have, in a way, developed a kind of societal immune system. But there are also hidden costs. Rapid adaptations, by their nature, are not always elegant, long-term solutions. They are often messy, and they can introduce new and unexpected behaviors into the system. Consider the speed of innovation. The pace of mRNA vaccine development was a marvel of science. But for some, it also fed a narrative of rushed, untested technology that fueled skepticism. The adaptation that saved millions of lives also created a new vector for social division. We solved a biological problem but perhaps deepened a social one. Consider the economic adaptations. The unprecedented stimulus packages that prevented a deeper depression in 2008 and 2020 have led us into uncharted territory. By repeatedly intervening in market cycles, have we created a system that is dependent on a perpetual flow of support, unable to withstand even minor shocks without another massive intervention? We averted the collapse, but we may have created a system that is simultaneously more fragile. There is also the human cost of living in a perpetually adapting reality. Constant change is exhausting. It leads to burnout for those on the front lines. For the general public, it can create a profound sense of unease, a feeling that the ground is never truly stable. When the rules can be rewritten at any moment, it becomes harder to trust the system itself. This erosion of trust may be the most serious long-term consequence of all. This leads to the biggest question: is this adaptive capacity sustainable? Can a system adapt indefinitely? One school of thought argues that this is simply the next stage of our evolution. Complex adaptive systems, from ecosystems to economies, are meant to behave this way. Crises are the primary drivers of evolution. What we are seeing is not a breakdown, but a difficult, yet necessary, leveling up of our global operating system. We are becoming a civilization that learns and grows stronger from shocks. The other, more cautious view, is that we are simply drawing down our reserves of resilience. Each adaptation, each bailout, each emergency recall, each bending of environmental law, is like taking a loan from the future. The Tylenol crisis was resolved because Johnson & Johnson had a massive reservoir of public trust to draw from. Financial systems were saved because there was still enough faith in central banks to make their interventions credible. With each crisis, that reservoir of trust may shrink. One day, we may go to that well and find it empty. Conclusion: so where does that leave us? We find ourselves in a world that feels both more resilient and more fragile than ever before. We survived the unthinkable, not through sheer strength or luck, but through a series of quiet, strange, and often desperate adaptations in the very code of our reality. We learned that our systems have a hidden capacity for change, a flexibility we may not have known they possessed. We saw hospitals rewrite their own rules to save lives, corporations embrace transparency to regain trust, and governments bend the laws of finance and physics to keep the world moving. But we've also learned that these adaptations are not a perfect solution. They come with costs, social, psychological, and systemic. They are a testament to our ingenuity, but they are also a quiet warning about the accumulating debt of our constant improvisations. The story of the last few decades is not one of near collapse. It is the story of a world that did, in a way, collapse, but did so in a quiet, controlled, and uneven way, immediately patching itself back together with whatever materials were at hand. We are living in the world that was built from those patches. The old narrative of resistance is fading. The idea that we can build walls high enough to keep out the chaos of the 21st century seems like a story from a past era. The future seems to belong to adaptation, to resilience, to the ability to change form. The survival of our civilization may depend not on our ability to prevent the next crisis, but on our ability to successfully adapt our way through it. And that leaves us with one final, quiet question. We've seen the healthcare adaptation, the tech adaptation, and the infrastructure adaptation. We are living through the consequences. But what will the next adaptation look like? And when it happens, will we have enough trust, ingenuity, and collective will left to navigate it one more time? Your brain is lying to you about reality. What if the world you experience, the stable and predictable reality you inhabit, is not a direct reflection of what is there? What if, after the most significant shock of your life, your brain's first response is not to process the truth, but to construct a lie? It activates a quiet, secret survival mode, creating a convincing sense of continuity to shield your conscious mind from chaos. This is not speculation, it is a powerful illusion, generated by the brain when the world as you know it comes apart. Picture the architecture of a life. A career, built over years of effort, vanishes after a single notification. A relationship, once believed to be permanent, becomes a space where a future used to be. Or perhaps the shift is larger, a global crisis that redraws the rules of society, seemingly overnight. Stability is gone. It has fractured into unfamiliar pieces. And yet, the next morning, you might wake up. You might prepare coffee. You might scroll through the internet. You may even feel a strange, hollow sense of calm and think, everything is fine. What is happening? Why is there this profound disconnect between an external catastrophe and the quiet inside? Your brain is engaged in a sophisticated act of preservation. It is actively constructing a sense of normal when reality is in ruins. This is not a flaw in its design, it is a feature. It is a deeply embedded, ancient survival protocol, intended to keep the mind from shattering along with the world it perceived. But this protective mechanism has a hidden cost. It builds a temporary shelter that can, over time, become a permanent prison. Today, we will explore the neuroscience behind this powerful illusion. We will examine the mechanisms the brain employs without your permission. We will investigate why, in the face of disaster, the mind's first instinct is often not to confront reality, but to build a more manageable one. And most importantly, we will uncover how to recognize the fractures in this fabricated world, and how to find a way back to what is real. Section 1. Setting the stage, the illusion of continuity. Before we investigate the neurobiology, it is important to be clear about what we are going to uncover. This is not about simple optimism or positive thinking. It is about a profound, automated, and biological process. We are going to explore the brain's quiet survival toolkit, the shield of denial that deflects initial impact, the distortion filters that bend reality into a more tolerable shape, and the dissociative states that can make you feel like a spectator in your own life. Our exploration is grounded in decades of trauma studies and modern neurobiology. We will touch on the work of neuroscientist Anil Seth, who argues the brain is a prediction machine, constantly generating a controlled hallucination that we experience as reality. We will also reference the work of psychologist Lisa Feldman Barrett, whose theory of constructed emotion helps provide a framework for understanding how these cognitive illusions are not merely thoughts, but are felt deep within our bodies. By the end of this, you may not only understand this phenomenon in an abstract sense. You may see parts of your own life reflected in it. You might recognize moments where your own brain was quietly editing your reality to protect you. And you will be left with the tools to begin distinguishing between the story your brain tells and the truth of your experience. This is the story of how the brain fakes continuity until it can make a new one, or until the fake one begins to crumble. Section 2. The collapse, when stable reality vanishes. So, what is stable reality? The term sounds grand, but it is built from the most ordinary and predictable parts of life. It is the invisible architecture of routine. It is the quiet confidence that a key will turn in a lock, that the sun will rise, that people you know will be there tomorrow. It is the job you attend, the rhythm of a week, the unspoken social contracts that make the world feel coherent and safe. It is the hum of a system working as it should. And then, one day, it does not. The collapse of this stable reality is not always a dramatic, cinematic event. Often, it is a personal apocalypse. It is the sudden loss of a job that erases a professional identity. It is the phone call in the middle of the night that delivers news from which there is no immediate recovery. It is the quiet, creeping discovery that a relationship that once structured your world is over. Or, it can be a collective shock. A pandemic that alters global society, an economic recession that removes security for millions, a natural disaster that remakes a landscape. In that moment of impact, the brain has no time for nuanced debate. It does one thing, and it does it with speed. It activates an alarm. The brain's ancient threat detection system, the amygdala, goes into overdrive, signaling threat. Your heart rate may increase. You may feel a sense of unreality, a disorienting panic. This is the moment the brain's survival mode is initiated. Let us make this concrete. Consider a person named Sarah. For 15 years, her stable reality was a fortress. A steady career, a long-term partner, a life structured around school schedules and routines. The world was predictable. Then, a global crisis emerges. It begins as a distant event, then becomes a series of notifications. The office is closing. Her position is eliminated. The schools are shutting down. In 72 hours, the architecture of her life is gone. Day 1 is characterized by panic. A tightness in her chest, a mind replaying what ifs. The world feels sharp and hostile. But then, something curious happens on day 3. The raw panic recedes. Sarah wakes up, and instead of confronting the void, she decides to bake bread. She reorganizes the kitchen. She creates a color-coded schedule for her children and calls it a new family adventure. She communicates with friends with a bright expression, talking about the benefits of a break from her previous routine. This is not a conscious deception. A part of her genuinely believes it. Why? What happened to the terror from day 1? It did not disappear. It was moved out of conscious awareness by her own brain. Facing a reality too chaotic to process, her brain engaged in emergency override. It rebooted her sense of continuity. It began constructing a new, temporary reality, one where she is not a terrified, unemployed woman in a crisis, but a proactive, resilient person making the best of a strange situation. The chronic stress is still there, simmering beneath the surface, rewiring neural pathways and creating conditions where depression and anxiety might later emerge. But for now, the first and most powerful defense has been deployed. The illusion of normalcy holds. And for a time, it works. But how does the brain accomplish this? How does it build a quiet room when the world outside is in upheaval? That is where we will go next. The brain's illusion machine, the 4 key mechanisms. The human skull, the dark, silent space where we live our entire lives, contains a sophisticated system for generating reality. When faced with a crisis that threatens to overload its circuits, it does not just process raw, threatening data. It begins to render a more palatable world. This is not a single trick. It is a coordinated suite of psychological and neurological programs designed to create continuity. Let us break down the 4 key mechanisms the brain uses to convince you that things are normal. Mechanism 1. Denial and cognitive appraisal, the reality shield. The first wave of defense is often the most direct, denial. This is not a matter of being stubborn or foolish. It is a primal, adaptive response designed to buffer the nervous system from a catastrophic shock. It functions as a psychological circuit breaker. When an overwhelmingly painful or threatening reality enters the system, denial trips the switch, preventing a complete meltdown. It is the mind's way of determining, we cannot process this right now. This provides the mental and emotional space to gradually adjust to a new, threatening truth. On a neurological level, this is a tangible process. During an acute shock, the brain actively prioritizes survival over accuracy. The prefrontal cortex, the logical, analytical part of the brain, has its communication with emotional centers, like the amygdala, disrupted. Resources are diverted from higher-level critical thinking toward immediate, reflexive responses. You are not thinking your way through the crisis. Your body is reacting to survive it. This initial shock is often followed by a process known as cognitive appraisal. First conceptualized by psychologist Richard Lazarus, cognitive appraisal is the brain's instant, often unconscious judgment of a situation. It is the process of asking, is this a threat? And if so, can I handle it? In the aftermath of a shock, the brain can engage in mental gymnastics to reappraise a catastrophe as something manageable or temporary. It reframes, I just lost my job, into, this is a temporary setback, an opportunity for a new beginning. The brain does not fail to register the event. It actively recategorizes it to prevent overwhelming emotional distress. When Sarah begins baking bread, her brain is deep in this process. Denial buffered the initial panic. Now, cognitive appraisal is reframing the threat of unemployment as a challenge she can overcome. The shock numbs the raw edges of reality, making it feel more like a film she is watching than a life she is living. The apocalypse outside feels less real than the tangible reality of the rising dough in her hands. This is an effective short-term strategy. But denial is a temporary shield. It was never meant to withstand a sustained siege. Mechanism 2. Distorted filters and negative loops, the altered lens. If denial is the shield, cognitive distortions are the altered lenses the brain installs in the aftermath. They do not block reality entirely, they just bend it into shapes that are easier to view, or, in some cases, shapes that confirm our deepest fears. Cognitive distortions are flawed patterns of thinking that feel completely true in the moment. They are the software that runs on the hardware of a traumatized brain. These distortions are not created in a vacuum. They are often amplified by pre-existing mental landscapes. If a foundation of anxiety or low self-esteem is already present, a major shock will act as a massive amplifier for those negative thought patterns. The brain, in its attempt to make sense of chaos, will default to its most well-worn neural pathways. If those pathways are carved by self-criticism and worry, that is where the energy will flow. Consider someone going through a sudden, painful breakup. Their statement, "I'm fine, there are other options," is a form of cognitive reappraisal. They are minimizing the pain to avoid being consumed by it. But beneath that, other distortions may be operating. There might be personalization, the secret belief that, "this is all my fault." There might be catastrophizing, the thought that, "I will be alone forever." These distortions create an internal experience of the world that is warped and painful, even if the external world appears normal. This process often creates feedback loops. A distorted thought, "I am a failure because I lost my job," triggers a stress response in the body. That stress response, in turn, reinforces the neural pathways for negative thinking, making the distorted filter stronger and more believable. You feel bad, so you think negative thoughts, which makes you feel worse, which makes the thoughts seem even more true. For Sarah, her initial positive spin, "this is a new adventure," is one type of filter. But as weeks turn into months, other filters might appear. She might see a friend post about a work success and think, "everyone is coping better than me," an example of an unfair comparison. Or she might receive a rejection for a job and think, "I will never work again," which is all or nothing thinking. Her brain is trying to create a narrative to explain the chaos. Often, the easiest narratives to build are those that confirm pre-existing insecurities. The altered lenses are no longer helpful, they are just showing twisted versions of reality. If this exploration into the brain's architecture helps you understand the world within, consider subscribing to the channel. We explore these kinds of topics every week, and by joining our community, you can continue these calm investigations with us. Mechanism 3. Dissociation, the detached observer. Now we arrive at the brain's ultimate escape mechanism, its most profound and unsettling trick: dissociation. If denial is a shield and distortion is an altered lens, dissociation is the act of leaving the building entirely while your body stays behind and goes through the motions. It is the brain's primary, numb out, tool, and it is one of the most common responses to severe trauma and shock. Dissociation exists on a spectrum. At one end is the mild experience of zoning out while driving a familiar route. At the other end is a persistent and distressing clinical condition. After a major shock, many people land somewhere in the middle. This often manifests in two distinct ways. 1. Derealization. This is when the world around you begins to feel unreal, foggy, or dreamlike. Colors might seem muted, sounds might feel distant, and everything can take on a flat, two-dimensional quality, as if you are watching your life on a screen. The world loses its sense of vibrancy. 2. Depersonalization. This is the feeling of being detached from your own body, thoughts, and feelings. You might feel like an outside observer watching yourself. People describe it as feeling like a robot or a ghost in the machine of their own life. You are aware you are having emotions, but you cannot feel them. There is a glass wall between you and your own experience. Neurologically, Dissociation is believed to be a complex defense mechanism involving the inhibition of emotional circuits. When the amygdala sounds an alarm, the prefrontal cortex can, in some cases, respond by applying the brakes so hard that it effectively shuts down emotional processing centers like the insula, which is involved in interoception, your sense of your body's internal state. This emotional shutdown produces the feeling of numbness and detachment. It is a survival strategy. If the feelings are too overwhelming to bear, the brain unplugs the machine that feels them. This is a common experience for survivors of accidents, assaults, or disasters. They might describe the event with a surprising lack of emotion, not because they are unfeeling, but because their brain has defensively disconnected them from the horror of the experience. It allows them to continue performing essential tasks, finding help, getting to safety, without being paralyzed by terror or grief. In Sarah's story, this might surface a few months into her new normal. The novelty of baking has worn off. The stress is mounting. One afternoon, she might be helping her children with schoolwork and suddenly be struck by a profound sense of unreality. The room looks strange, her children's voices sound far away, and she feels a chilling detachment from her own hands. She is on autopilot. This is not laziness or apathy. It is her brain's last-ditch effort to protect her from cumulative stress. It is the ultimate lie. This is not really happening to you. Mechanism 4. Emotional buffering and loss of grounding. The final mechanism is more subtle but just as significant. It is what happens when the initial shock has passed, but the new reality has not fully set in. This is the liminal space of emotional buffering and grounding loss. When our stable reality shatters, we lose our anchors. The routines, roles, and relationships that used to ground us and define who we are suddenly gone. Without these anchors, the brain can drift into a state of apathy and numbness. This is not the dramatic detachment of dissociation, but a more pervasive, low-grade emotional fog. It is a form of emotional buffering, where the brain dampens all emotions, good and bad, to conserve energy and prevent further shocks. The highs are not as high, and the lows are not as devastating. The result is a flat, gray emotional landscape. This state can lead to paradoxical behaviors. A person might seem calm and functional on the surface, but underneath, their resilience is worn thin. Minor stressors that they would have once handled, a misplaced set of keys, a critical comment, can trigger disproportionate outbursts of anger or tears. This happens because the brain is using all its available energy to maintain the illusion of continuity, leaving no bandwidth for regulating everyday frustrations. In this state of grounding loss, people often begin to seek external validation to feel real again. They might cling to a new relationship, a new hobby, or become focused on their social media presence. They are looking for a new anchor, something to tether them to a sense of self now that their old one is gone. This is the phase where Sarah's illusion might truly begin to show its cracks. The sourdough starter is gone. The color-coded schedules are abandoned. She is going through the motions, but the world feels colorless. She finds herself scrolling endlessly on her phone, feeling something that is not quite envy or sadness at her friends' seemingly normal lives. She might react with anger when her kids spill milk, then be flooded with guilt and shame. She feels as though she is holding her breath, waiting for something to happen, waiting to feel like herself again. But she cannot, because the self she knew was tied to a world that no longer exists. These four mechanisms, denial, distortion, dissociation, and emotional buffering, are the pillars of the fake continuity the brain constructs. They are brilliant, life-saving adaptations in the short term, but they are built on a foundation of untruth. And eventually, all such structures begin to weaken. The Neuroscience Deep Dive: Why the Lie Feels So Real. We have discussed the psychological strategies the brain uses. But why do these illusions feel so convincingly real? The answer lies deep in the wiring of our brains, in the complex dance of neurochemicals and the very structure of how we perceive the world. This is a matter of biology. At the core of this phenomenon is a concept known as affective dysregulation. In simple terms, this means that trauma and severe shock throw the emotional regulation system out of balance. Clinical studies have shown a strong link between this emotional dysregulation and reality distortion. When your emotions are in chaos, your perception of reality becomes unstable. The brain, in an attempt to explain the intense and confusing internal signals it is receiving, starts to misinterpret the external world. This can lead to a process of aberrant salience, where the brain starts assigning huge importance to neutral, everyday things. The sound of a bird might suddenly feel like a sinister omen, or a stranger's neutral expression might be interpreted as hostile. Your emotional state is literally coloring your perception of reality. Much of this comes down to neurochemicals. When you experience a trauma, your brain is flooded with stress hormones like cortisol and catecholamines. While these are essential for the fight or flight response, chronic exposure changes how your brain functions. The dopamine system, which is crucial for motivation and registering what is salient or important, can begin to glitch. This can cause the brain to assign motivational significance to random stimuli, laying the groundwork for delusional thinking. The mechanism for assigning importance begins to function erratically. Furthermore, the architecture of the brain itself can change. Key brain regions are physically altered by trauma. The amygdala, the threat detection center, can become hyperactive, leaving you in a state of constant hypervigilance. It starts seeing threats everywhere. At the same time, the hippocampus, which is responsible for contextualizing memories and telling the difference between past and present, can shrink in volume and become less effective. This is why traumatic memories can feel so present. The hippocampus is failing to label them as past. Most critically, the connection between the prefrontal cortex, the rational brake, and the amygdala, the emotional gas pedal, can become impaired. Normally, your prefrontal cortex can send a signal to the amygdala to say, "Calm down, that loud noise was not a threat." But after trauma, that signal gets weaker. The amygdala continues to signal danger, and the rational part of your brain cannot quiet it. Your body is stuck in a state of high alert, even when you consciously know you are safe. This entire process is rooted in the fundamental way our brains operate. Neuroscientist Anil Seth puts forward the idea that our brains are prediction machines. He argues that perception is not a passive process of taking in information. Instead, your brain is constantly making its best guess about what is out there, then using sensory information to update those guesses. What you experience as reality is a controlled hallucination generated by your brain. When a massive shock occurs, the incoming sensory information is chaotic and does not fit the brain's old predictive models. The world is no longer predictable. So, the brain clings to its old models. It generates the prediction of normalcy and continuity, and then selectively ignores or reinterprets the chaotic data that contradicts that prediction. The lie feels real because, to your brain, all perception is a constructed best guess. In a crisis, it just guesses in favor of survival over accuracy. Conclusion: breaking the illusion and reclaiming reality. The final day of your old, stable reality likely passed without notice. In its wake, your brain, the silent protector in your skull, began to construct a sense of continuity on top of the rubble. It was an elegant, evolutionary survival move. And for a while, it worked. It kept you from shattering. But there is a problem with living in a structure built from illusion. It can become a prison. That temporary shelter can become a cage that cuts you off from genuine experience, authentic connection, and the messy, painful, but ultimately meaningful truth of your own life. The goal is not to shame the part of the brain that built this illusion. The goal is to acknowledge its service, and then gently, compassionately, begin the process of moving beyond it. How does one begin to dismantle this cognitive scaffolding? The first step is to learn to recognize the signs. Recognizing the illusion for what it is reduces its power. Pay attention to the dream world feeling, the sense that you are watching your life from a distance. Notice the emotional glass wall. Listen for the mantra of, "I'm fine," especially when your body tells a different story through tension or exhaustion. Once you can see the illusion, you can begin the work of returning to reality. This is often done with three powerful tools. 1. Cognitive restructuring. This is the manual version of what the brain did automatically. It is the process of actively identifying, challenging, and reframing distorted thoughts. When the thought, "I'll never recover," appears, you do not just accept it. You question it, you look for evidence, you formulate a more balanced thought. This is difficult, and it will take time to heal, but I can take small steps forward. This is the core of cognitive behavioral therapy, CBT, a proven method for rewiring these feedback loops. 2. Mindfulness and grounding. If dissociation is floating away from your body, grounding is intentionally coming back into it. Grounding techniques are simple, sensory-based exercises designed to pull your attention out of the narrative in your head and into the physical reality of the present. A common technique is to name 5 things you can see, 4 things you can feel, 3 things you can hear, 2 you can smell, and 1 you can taste. This anchors you in your senses and signals to your nervous system that you are here, now, and safe. Mindfulness, more broadly, is the practice of paying attention to the present moment without judgment, which slowly rebuilds the mind-body connection that trauma can sever. 3. Seeking support and professional help. You do not have to do this alone. In fact, healing often happens in connection. Talking to trusted friends, family, or a therapist can be a powerful antidote. Therapies like eye movement desensitization and reprocessing, EMDR, and somatic experiencing are designed to help the brain and body process traumatic memories that have become stuck. A good therapist provides a safe container in which you can begin to touch those painful realities your brain worked to hide, allowing you to finally process them. Your brain told you a story to keep you safe. Understanding this process is the key to reclaiming your role as the author of your life. You can acknowledge the fear, pain, and chaos without letting them define you. Reality is messy, unpredictable, and often painful. But it is also the only place where true joy, real connection, and authentic healing can be found. There is something quietly humbling about this process. It reminds us that our experience of the world is a careful construction. And knowing the architect is the first step toward living comfortably in the world as it truly is. Sharing our understanding of these processes is one of the most powerful ways we can break through illusions together. If this exploration helped you understand your own mind a little better, consider sharing it with someone who might need to hear this message. Because the first step to finding reality is realizing you have been living in a controlled hallucination. You don't live in reality anymore. There is a solidity to the world we think we know. Go on, look at your hands. They feel like your own. The thoughts in your head, the life you see when you look up from this screen, these things feel real. They feel like they belong to you. But what if that feeling of reality, that solid ground, wasn't quite what it seems? What if it was more like a stage, a set built just for you, held together by invisible forces you were never meant to see? This isn't a story about the future. This is a journey into the world we inhabit right now. A world where that single, shared reality has quietly fractured into billions of personalized streams. And the strangest part isn't that this happened. It's that we barely noticed it at all. What if the things you chose today weren't really choices? That cafe you found through a map recommendation, that news story that made you feel a flash of anger, that sudden urge to buy something you didn't know existed 5 minutes ago. You feel like you decided on them. But what if they were props, carefully placed in your world by a handful of engineers you'll never meet. This is the story of how our reality has been subtly replaced by something else, and what we can do once we see it. The revelation. To understand the world we're in, we have to remember the one we left behind. For a long time, humanity operated within a kind of shared story. We read from a small number of newspapers, watched one of a few news channels, and our information came from institutions we broadly trusted. The truth felt anchored. We lived by grand narratives. The idea of progress, a stable career, a sense that someone was steering the ship. The world, for all its flaws, felt predictable. But then, tiny fractures began to appear. Technology accelerated. Trust in those large institutions began to erode after decades of scandals, wars, and inequality. And into our lives came a new force, one that promised to connect us, to give us a voice, to show us a world perfectly suited to our desires. That force was the algorithm. And it marked the end of that stable, shared reality. What came next wasn't chaos. It was something far stranger. A new world held together by a kind of asterisk conditional coherence. Think of a Jenga tower. It stands, it seems stable, it works, but only on the condition that you don't pull out the wrong block. Your life today is a bit like that Jenga tower. It feels coherent, but it's fragile. This idea of coherence is something philosophers have explored for a long time. There's a theory that a belief is justified not because it rests on a single, solid truth, but because it connects to a whole web of other beliefs that support each other. The problem is, when there's no solid ground to anchor it, the entire web can become untethered from reality itself. This is what has happened to us. The old anchors, shared facts, trusted institutions, are fading. In their place, we've each built our own small, personalized web of belief. It's your social media feed, your YouTube recommendations, your news alerts. And it feels coherent. It makes perfect sense to you, because everything in it reinforces everything else. But it's fragile, because it's built on the condition that the algorithm keeps feeding you the right information, and that nothing from the outside world punctures the bubble too violently. The story is also about how we make sense of this change. The scholar David Harvey once described a shift away from a world of order and into one of fragmentary and chaotic currents. He saw society breaking into smaller and smaller pieces. What he couldn't have predicted was the force that would step in to manage that chaos. Not a government or a philosophy, but code. Algorithms became the invisible glue, giving us a asterisk feeling of stability while the ground beneath us had turned to sand. The architects of your world. So how did this happen? How did we hand over the architecture of our world to a machine? It all began with a simple and seductive promise: relevance. At its core, an algorithm is just a recipe for a computer. The ones that guide our digital lives have a simple goal: figure out what will keep you, specifically, engaged for as long as possible. To do this, they watch. They track every click, every like, every search, every second you spend on a video. They're building a digital shadow of you, a blueprint of your attention. And their goal is to get that model to be a better predictor of your behavior than you are. They have become remarkably good at this. Take a platform like YouTube. A huge portion of the time people spend watching videos isn't driven by their own searches or subscriptions. It's driven by the recommendation engine. For hours at a time, you're watching what the algorithm has chosen for you. It's less like a library where you choose your own book, and more like a guided tour where the path has already been set. This is the engine of what activist Eli Pariser called the filter bubble back in 2011. He explained that these algorithms aren't just showing you what you might like, they are also, crucially, hiding everything else. They become an invisible editor for your experience of the world. But unlike a human editor, this one has no civic duty, no desire to show you what's important or true. Its only goal is to show you what is most you. Pariser described how this process, happening without our knowledge, creates a unique universe of information for each of us. It leads to a strange state where two people can search for the same term and see strikingly different results. One person searching for BP might see investment news, while another gets pages about an oil spill. Neither is seeing the whole picture. Each is seeing a version painted for them. The algorithm acts as a lens you don't know you're looking through. This can create what we call an echo chamber. If the filter bubble is the boundary around your world, the echo chamber is what happens inside. You are surrounded by voices that confirm what you already believe. Dissenting opinions aren't just ignored, they can become invisible. Over time, this has a powerful effect. Your beliefs, rarely challenged, grow more rigid. Your idea of the other side becomes a caricature because you only ever see the distorted version your own side presents. Let's imagine an experiment. Two people with different browsing histories sit at two computers. Person A often reads about climate action. Person B tends to view content skeptical of climate science. They both open their news feeds. Person A sees a story about a new UN climate report. Person B sees an opinion piece on the economic costs of green policies. They both go to YouTube. Person A is recommended documentaries about saving the oceans. Person B is shown videos questioning climate models. After an hour, they haven't just consumed different information. They have lived, for a time, in different realities. To Person A, the climate crisis is an urgent threat. To Person B, it's a political debate. Neither is acting in bad faith. Both are responding rationally to the information they were given. The problem is, neither knows their universe is just one of billions, each one perfectly sealed. This is the world the architects of code have built. Not one world, but billions, all running in parallel. The illusion shatters. This system would be strange enough if it only influenced what videos we watch. But it goes deeper. It has begun to re-engineer our society, our politics, and our sense of self. It has brought us into a state that the sociologist Jean Baudrillard called hyperreality. Hyperreality is a condition where the simulation of a thing becomes more real to us than the thing itself. Social media, you could argue, is the ultimate engine of hyperreality. It's not a window into the world. It is a world unto itself, a simulation that we often prefer to the messy, unedited truth. We can see this in our social hyperreality. Think of an Instagram feed. It's a highlight reel, the perfect vacation, the beautiful meal. We know this isn't the full picture. But the constant flood of these perfect simulations can blur the line. The curated image of a person's life can start to feel more real than the complex, flawed human we know. Their representation replaces their reality. This extends to our most basic social units. For many, the family group chat has become the primary place for family interaction. The digital version of the family, a stream of texts and photos, can feel more immediate than the physical family, which might be scattered. It is a simulation, but it's a simulation that dictates the emotional reality of the family. Then there is political hyperreality and this is where the consequences become more serious. The filter bubble doesn't just show us news we might like, it can create entirely separate political realities. People on opposite sides of an issue are often not just disagreeing on policy. They're operating from different sets of facts, fed to them by their feeds. This fuels a kind of polarization where it's not just that we disagree with the other side. We begin to distrust them as people, because their reality seems so alien to our own. In his farewell address, President Barack Obama spoke of this danger. He warned of our tendency to retreat into our own bubbles, surrounded by people who look like us and share the same political outlook and never challenge our assumptions. He argued this is a threat to democracy itself, because democracy requires some shared basis of fact to function. Today, this is being supercharged by AI. The rise of AI-generated content means that a simulation can be made perfectly realistic. While detection technologies have also advanced, we are in a kind of arms race between creation and verification. A fake video of a politician can spread through a filter bubble, where it's accepted as truth because it confirms what people already believe. The digital sign has no connection to reality, but it creates a real-world effect. It's the map of the world replacing the territory entirely. Finally, there is cultural and economic hyperreality. Our identities are shaped by these fragile systems. A TikTok trend can create a subculture overnight. A person can adopt a new identity that is built and sustained almost entirely through their interaction with the algorithm. The identity feels real, but it is conditional on the trend remaining popular. The gig economy is another fascinating example. An app for a delivery service presents a simulation of freedom. You're your own boss. But in reality, the driver is often guided by the algorithm, which dictates their work and their pay. The feeling of freedom is the hyperreal simulation. The reality is a complex relationship of algorithmic management, though one that is also being shaped by new regulations and worker protections. In all these corners of our lives, we see the same pattern: beautifully constructed simulations that feel coherent, but are fragile and conditional, ready to wobble the moment they are confronted with something that doesn't fit. The turning point. Listening to all of this, it's easy to feel a sense of powerlessness. If our worlds are being shaped by code we can't see, what can we do? This is the turning point. Because the moment you understand the architecture of this system, you've found the beginning of a path. The most dangerous part of the filter bubble is that it's invisible. Once you can see it, its power is diminished. Awareness is the start of agency. The system is designed for passive consumption. It relies on you scrolling, reacting, and operating from what psychologists call an external locus of control. The belief that your life is shaped by outside forces. The solution, then, is to begin to cultivate an internal locus of control. The belief that you are the primary driver of your choices. This isn't about deleting everything and moving to a cabin. It's about changing how you engage with the digital world. It's about becoming a conscious and intentional user. It is about declaring that your mind is not territory to be colonized by an algorithm. It is sovereign ground. So, what can we do? How can we begin this journey of reclaiming our own reality? It begins by building a set of practices, a way of moving through this new world. The solution: breaking free isn't a single act, but a continuous practice, like developing a new kind of mental hygiene for our time. Here are 5 things to explore, starting today, to see outside your bubble and begin to build your own reality. 1. Conduct a quiet audit of your information diet. You wouldn't want to eat only junk food. The same principle can be applied to information. For 1 week, become a quiet auditor of your feeds. As you scroll, ask yourself 3 questions for each piece of content. Why am I being shown this? What emotion is it trying to spark in me? And does this make me feel more informed or more anxious? The outrage content that gets your blood boiling? That's the junk food, designed for an emotional reaction. The endless stream of gossip? Junk food. Content that only ever reinforces what you already believe. That can be junk food, too. Identify these sources and gently curate your space. Use the unfollow, mute, or show me less buttons. You are not censoring, you're tending to your own mental environment. The algorithm learns from you. When you stop engaging with low-quality, rage-baiting content, it will slowly stop serving it. You have to train your algorithm, or it will continue to train you. 2. Intentionally seek out friction. The algorithmic world is designed to be frictionless and comfortable. Your job is to reintroduce a little friction. Friction is where learning happens. It's where the real world, in all its complexity, lives. You can start by turning off autoplay on platforms like YouTube. Autoplay is the enemy of intention. Make a conscious choice about what to watch next. Don't let the code decide. Use different tools. Search for important topics in a private browsing window to get less personalized results. Try a search engine like DuckDuckGo, which doesn't track you. This offers a glimpse of the web outside your bubble. Most importantly, actively seek out thoughtful people and credible sources who disagree with you. The goal is not to argue, but to listen. Follow writers or journalists from a different perspective. Try to understand why they believe what they believe. The point isn't to change your mind, but to complicate your own story. It's to replace the caricature of the other side with a more human picture. 3. Treat your feed like a garden. Right now, your feed might feel like a river that flows past you. You can start treating it like a garden that you must actively cultivate. This means planting seeds. Think about subjects you're curious about. Actively search for and follow experts in those fields, historians, scientists, artists. Use the search bar as an exploration tool. It also means noticing the weeds. When you see misinformation, consider using the report function. You're not just improving your own experience, you're sending a small signal that can help the whole ecosystem. A garden requires attention. Curating your information space is an ongoing practice of intentionality. 4. Build reality anchors. The digital world is designed to be all-encompassing. To counter this, you can build strong anchors in the physical, non-digital world. Talk to your neighbors, especially the one with the political sign you disagree with. You don't have to talk about politics. Human-to-human interaction is a powerful antidote to the dehumanizing effects of online discourse. Read physical books. A book is a deep, linear, non-algorithmic journey. It requires sustained attention and presents a complex argument from a single perspective. It's a workout for your attention span, which has been reshaped by the short-form nature of feeds. Engage with your local community, a farmer's market, a local concert. These are spaces of uncurated reality, filled with people and ideas you would never find in your feed. These experiences are anchors, tethering you to the shared, physical world. 5. Develop your sense of coherence. Finally, the most powerful tool is an internal one. The sociologist Aaron Antonovsky studied why some people endured extreme stress and remained healthy. He found they shared a sense of coherence, built on 3 core beliefs. That the world was *comprehensible, it makes sense, manageable, they can cope, and *meaningful, life is worthy of engagement. The algorithmic world can undermine all 3. It presents a chaotic flood of information that feels incomprehensible and a sense of powerlessness that feels unmanageable. Building your own sense of coherence is an act of quiet rebellion. Cultivate comprehensibility. Don't just consume headlines. When a big event happens, take the time to read a long-form article to seek understanding, not just information. Cultivate manageability. Focus on what you can control. You can't fix the whole internet, but you can control your own feed and your own attention. Each small, intentional choice builds your sense of agency. Cultivate meaningfulness. Engage in activities that provide purpose outside the digital realm, creative work, volunteering, time in nature, real-world relationships. These are the things that provide a why strong enough to resist the algorithm's pull. These 5 practices are not easy. They require effort and intention. But they are the work required to be a free-thinking person in the 21st century. Conclusion. We are at a crossroads. We can continue to drift passively in our personalized realities, allowing invisible code to steer us further into fragmentation. Or we can wake up. We can recognize that reality is not something delivered to us through a screen. It is something we must actively build together. The systems built around us are designed to make us predictable, to turn the beautiful and messy chaos of human consciousness into a neat set of data points. But you are not a data point. You are not a profile to be targeted. You are a sovereign individual with the power of awareness, intention, and choice. The algorithm is powerful, but consciousness is a far stranger and more powerful thing. It built a world for you. Now, you can begin to build your own. We already passed the point of no return. Ecosystems, like animals, have lifespans. Some are fleeting, while others feel as old and permanent as the world itself. A coral reef is one of those ancient systems. A sprawling, intricate world of life that has existed in our oceans for hundreds of millions of years. It feels eternal. But what we're looking at here is a system that has crossed an invisible threshold. The world you see is a ghost. It just doesn't know it yet. This isn't a story about a future we might lose. It's an exploration of a loss that has already happened. We tend to think the end of an ecosystem will be a dramatic, singular event. A moment you can point to on a calendar. But that isn't how it works. The end is a quiet process, a series of lines crossed over decades. And for the world's warm water coral reefs, the most important of those lines has already been crossed. We are now living in a world that has, for all practical purposes, lost this global ecosystem. The system just hasn't finished crumbling. This is an attempt to understand how that happened. To trace the history of a slow-moving fever and the planetary life support system it has begun to dismantle. Because this ghost has a warning for us. This is the story of that final, invisible line, and how we all stepped over it without noticing. The anatomy of a ghost. Before we can understand how this world is dying, we first have to understand how it lived. So, what is a coral reef? If you were to look closely, you might think you're seeing stone, or perhaps some kind of strange marine plant. But you'd be looking at something far stranger. A city, built by millions of tiny animals. Each one of those complex structures, the branches, the fans, the brains, is a colony of genetically identical creatures called polyps. And these polyps are unwitting architects. They pull calcium carbonate from the seawater to build their limestone skeletons. Generation after generation builds upon the skeletons of their ancestors, constructing cities so vast they can be seen from space. But they have a secret partner. The coral polyp is the builder, but it is not the power source. Living inside the coral's own tissue are microscopic algae called zooxanthellae. This is one of nature's most elegant partnerships. The coral gives the algae a protected home. In return, the algae use sunlight to create food, providing up to 90% of the coral's energy. And, as a byproduct, these algae are what give the coral its incredible color. So, a reef is like a city. The coral skeletons are the buildings. The fish and crabs are the inhabitants. And the zooxanthellae are the power grid, the food supply, and the art, all in one. They are what turn a limestone skeleton into a living metropolis. For hundreds of millions of years, this partnership has thrived, building the most biodiverse ecosystems on the planet. Though they cover less than 1% of the ocean floor, reefs support about a quarter of all marine species. Countless organisms depend on them. And so do we. Hundreds of millions of people rely on reefs for their livelihoods. They also form a natural barrier, absorbing up to 97% of a wave's energy to protect coastal communities. The value of the services they provide is estimated in the trillions of dollars every year. This is the system, a vibrant, ancient, and deeply important part of our planet. But what happens when that system suffers a catastrophic, worldwide power failure? That failure has a name: coral bleaching. When ocean temperatures get too hot, even by just 1 degree Celsius for a few weeks, the delicate partnership breaks down. Stressed, the algae begin to produce molecules that are toxic to their host. The coral has no choice. It forcibly ejects its partner. The polyps kick out the colorful, life-giving algae. What's left is the coral's transparent tissue over its white skeleton. The power grid is off. The color is gone. The coral isn't dead yet, but it's starving. It's a ghost of its former self. And if the heat doesn't go away, it will die. This is the mechanism of the collapse. For a long time, this was a rare, localized event. But in the late 20th century, something changed. The planet's oceans began to warm. And this started happening everywhere. The first signs of stress. To understand what's happening now, we have to look back to when the first signs of system-wide stress appeared. Before the 1980s, mass coral bleaching, the kind that stretches for hundreds of kilometers, was virtually unknown to science. But in 1983, and again in 1987, reports started coming in from around the globe. Reefs in the Pacific and the Caribbean were turning bone white. At first, scientists were unsure of the cause. But as they gathered data, a clear pattern emerged. Every major bleaching event was happening during years with unusually warm ocean temperatures, often amplified by El Niño cycles. The rising heat was the trigger. The first truly global bleaching event struck in 1998, fueled by a powerful El Niño on top of an already warming ocean. An estimated 16% of the world's shallow water corals died. At the time, it was viewed as a once-in-a-century catastrophe. Scientists warned that if warming continued, these events could become more frequent. The 2000s brought more bleaching. The Great Barrier Reef was hit hard in 2002. Another global event occurred in 2010. Each time, the pattern was the same: a spike in ocean heat, followed by bleaching. After an event, some reefs could slowly recover over a decade or more, as new corals settled on the old skeletons. But this recovery requires time. It requires a long period of stable, calm temperatures. And that is the key. A system can withstand a shock once every few decades. But it cannot withstand that same shock every few years. The oceans were absorbing over 90% of the excess heat trapped by greenhouse gases, and the quiet periods for recovery were getting shorter. Imagine a doctor seeing a patient. A severe fever once in a lifetime is serious, but the patient recovers. But then the patient starts getting a severe fever every other year, then every year. The doctor would realize they aren't treating isolated illnesses anymore. They're observing a chronic, systemic failure. This is what was happening to our oceans. The bleaching events of the 80s and 90s were the first symptoms. They were a warning of what would happen if the planet's fever wasn't brought under control. And as we entered the 2010s, that fever was about to escalate in a way the planet had never seen before. The accelerating pattern. A single event can be an anomaly. But a repeating pattern points to a fundamental shift in the system. What happened to the world's reefs after 2010 was a pattern of relentless, accelerating stress. The breathing room between heatwaves vanished. The second global bleaching event struck in 2010. But just 4 years later, in 2014, a third began. It would last for 3 years, becoming the longest and most damaging bleaching event ever recorded at that time. It hit the Great Barrier Reef with historic force. In 2016, an unprecedented marine heatwave cooked the northern third of the reef, causing catastrophic mortality in its most pristine, remote sections. Then, in 2017, just as the system was reeling, the heat returned, this time striking the central third. It was the first time the Great Barrier Reef had ever suffered back-to-back bleaching. The recovery window had slammed shut. Scientists who had dedicated their lives to the reef described a profound sense of shock and grief. The scale of the loss was difficult to comprehend. The world took notice, but the atmospheric and oceanic fever continued to rise. In 2020, the Great Barrier Reef bleached for a third time in just 5 years. But a particularly telling observation came in 2022. The reef bleached again, the fourth time in 7 years. This event was different because it occurred during a La Niña. La Niña is the cool phase of the Pacific climate cycle. It's meant to bring cooler ocean temperatures, a period of blessed relief for suffering reefs. It's supposed to be the recovery phase. The fact that a mass bleaching event could be triggered even during a cooler cycle showed just how much underlying heat the ocean had absorbed. The planet's natural air conditioning was failing to stop the fever. This relentless pattern was happening globally. The foundational corals of the Caribbean are now critically endangered. During the extreme heatwaves of 2023, Water temperatures in the Florida Keys reached as high as 38.3 degrees Celsius, over 101 degrees Fahrenheit, with some local reefs experiencing complete die-offs. This brings us to the present. In April of 2024, NOAA officially declared a fourth global coral bleaching event. It began in 2023 and became the most widespread bleaching event in recorded history. By early 2025, it was confirmed to have subjected a vast percentage of the world's reef areas to bleaching-level heat stress, far surpassing the previous record from 2014 to 2017. It's no longer about isolated incidents. It's about frequency. The average time for a reef to recover from severe bleaching is at least 10 to 15 years. We are now seeing major events every few years. The math is simple and brutal. The damage is happening much faster than the recovery. We are witnessing the systematic dismantling of a planetary ecosystem. All that's left is to identify the precise threshold that was crossed. Crossing the threshold. The term tipping point is used a lot, but it has a precise meaning in science. It's a threshold where a system is pushed into a new state, often abruptly and irreversibly. Imagine leaning in a canoe. You can lean a little, and it rocks back. Lean a bit more, and it still recovers. But if you lean just a millimeter too far, you cross a threshold. The canoe capsizes. You're in the water. The system has changed states. For decades, scientists have worked to identify this threshold for coral reefs. In its 2018 report, the Intergovernmental Panel on Climate Change, IPCC, made a stark prediction. It found that if global temperatures rise to 1.5 degrees Celsius above pre-industrial levels, we would lose 70 to 90% of our warm water coral reefs. At 2 degrees of warming, that number becomes more than 99%. 1.5 degrees. That was the edge of the canoe. For a long time, 1.5 degrees Celsius was a future possibility. But the conditions of that 1.5-degree world are no longer in the future. We've begun to experience them. While the long-term global average has been climbing steadily past 1.3 degrees Celsius, recent years like 2023 and 2024 have shattered records, pushing the planet's temperature temporarily above the 1.5 degrees Celsius limit for extended periods. Corals don't experience long-term averages. They experience the reality of specific heat waves. We are no longer approaching a 1.5-degree world. We are living in the heat waves of one. And the reefs are responding exactly as the science predicted they would. The confirmation of the tipping point is not a single event, but a new reality. The point of no return was the moment the climate system became so charged with heat that the frequency and intensity of marine heatwaves made widespread recovery for reefs impossible. The evidence strongly suggests that moment has now passed. The fourth global bleaching event, which began in 2023, is the confirmation. It is the canoe capsizing. Its unprecedented scale is the system telling us the threshold has been crossed. The bleaching of the Great Barrier Reef during La Niña was the final alarm. The natural safety mechanisms have failed. The conclusion of our exploration is this: the global warm water coral reef system has passed its tipping point. This doesn't mean every coral on Earth will be dead tomorrow. Small, resilient pockets might survive. But the interconnected, planet-spanning ecosystem that has existed for millennia is now on a path to functional collapse. We have crossed the line. We are living in the ghost system. And now we have to understand the consequences. The aftermath: living in a ghost system. So what does it mean to live in a world where a major ecosystem has passed this threshold? It's not a single, dramatic event. It's a slow cascade of consequences. The first and most immediate effect is a catastrophic loss of biodiversity. Reefs are the rainforests of the sea, supporting around a quarter of all known marine life. Over 4,000 species of fish alone rely on them. As the coral structures die and crumble, this city of life dismantles. The hiding places disappear. The food sources vanish. For the millions of species whose lives are tied to the reef, it's an extinction crisis. Then there is the effect on human economies. The livelihoods of over 500 million people are connected to the health of coral reefs. A 2020 report estimated their annual economic value at $2.7 trillion. Consider tourism. Australia's Great Barrier Reef alone has been valued at around $9 billion annually, supporting tens of thousands of jobs. When the main attraction is gone, the coastal economies built around it are left with a graveyard. And then there are the fisheries. Healthy reefs are nurseries for countless fish species. As the reefs collapse, so do the fish stocks. For many coastal communities, reef fish are a primary source of protein and income. The death of the reefs is a direct threat to their food security. Finally, there's a consequence that's often overlooked: the loss of our coastal defenses. Healthy reefs are incredible breakwaters, absorbing the vast majority of a wave's energy before it hits the shore. This protects hundreds of millions of people from storms and erosion. As the reefs crumble, that protection disappears. The cost of replacing this free service with man-made structures is astronomical. This is the reality of the ghost system: a less diverse ocean, crippled economies, and vulnerable coastlines. These are the locked-in consequences of a line we have already crossed. A warning from a ghost system. When we look back at the sequence of events, the early warnings, the accelerating pattern of bleaching, and the crossing of the 1.5 degrees Celsius threshold, a clear picture emerges. We watched it happen, we documented it, and we failed to act in time. At this point, a question comes up: but can't we fix it? There are incredible efforts underway. Scientists are growing corals in nurseries and replanting them. They are experimenting with super corals that have higher heat tolerance. These projects are acts of hope. They can buy time for local reefs and preserve genetic diversity for a future when conditions might be more stable. But we have to be realistic about the scale. Trying to restore the world's reefs while the ocean continues to warm is like trying to regrow a continent-wide forest with a handful of gardeners during a global wildfire. You might save a few precious groves, but you cannot save the forest. Restoration is a local solution to a global problem. As long as the planet's fever remains, any restored corals will simply bleach again. This is a difficult truth to accept. We cannot restore the global reef system to what it was. That world is gone. So, what is the path forward? It is not surrender. It is a shift in our perspective. The story of the coral reefs is a warning. It is the first time we have been able to watch, in real time, as a major planetary system crosses its tipping point. It shows us how it happens: a long period of accumulating stress, followed by a rapid, cascading collapse once a threshold is crossed. The reefs are the first domino. But there are others. The Greenland and West Antarctic ice sheets, the Amazon rainforest, they all have their own tipping points. Some of them are getting terrifyingly close. The path forward is to use this tragedy as a catalyst. The goal is no longer to save the reefs as they were, but to fight to prevent the other dominoes from falling. The purpose of this story is not to cause despair, but to use this knowledge to demand a change in course. It is to demand that we stop the fever, not to bring back what is already lost, but to save what is still living. Conclusion: we started by looking at a thriving, ancient system, an animal-built world that felt eternal. Now, we understand the quiet, relentless process that is unmaking it. The loss is profound, but despair is a luxury. The story of the coral reefs is the clearest signal we have ever received that our planet's systems have breaking points. We found this one by crashing through it. The end of an ecosystem wasn't a single, loud event. It was a line being crossed. And we are living through the beginning of other quiet ends right now. The question is no longer how we save the world that was. The question is, what will we do with the knowledge of what happened here, in the world that is? The fate of every other ecosystem on this planet may depend on our answer.